This is Qt 5 Design Patterns Section 1. This section is going to go over the course prerequisite, what the course is going to cover and not going to cover, along with some conventions and standards. We're going to make some mistakes, and these videos are going to be raw and unfiltered. What's important here is how do we get from start to finish? So I want to show every step in between, including some pitfalls and common mistakes. So you're going to see mistyping, I may mispronounce things, I may misspeak, but I want you to see the end-to-end process. We're going to go over what are design patterns, why we use them, along with the challenges of using these design patterns, and where to get additional help. Welcome to Qt 5 Design Patterns. If you're taking this course, you're like me, and you probably just want to skip the boring stuff and get right to the heart of the matter, because after all, nobody likes death by PowerPoint. While there's no code in this section, it does contain important information, disclaimers, and warnings. Do not skip this section. I promise I'll keep it short. The course prerequisites are off the chart for this class. I'm sorry, it is. This is not a beginner's course, and you're going to see that repeated over and over again. And I'm sorry to be obnoxious and repetitive about it, but this is not a beginner's course. I put that disclaimer on several slides because even in my advanced courses, I'll have people say things like, what is a variable? Or what is a class? They have no business being in the advanced course, and I have to stop everything and explain to them, look, you really shouldn't be here. You should be in the beginners or the intermediate class. And people don't like to hear that. So just disclaimer right up front, not a beginner's course. Here's a small list of some things you need to know. And I'm not going to read them all, but C++, Qt Creator, Qt Core, on and on and on and on, to the point I even put, are you still reading this? Because that's just a small list of some of the things you need to know. Honestly, there's more, and we're going to cover things without mercy. If you're taking this class, and I even put it in a different color, it's assumed you're at an advanced level looking to sharpen your skills. And you can research a lot of things on your own. For example, if we run a socket application and you're not an expert in sockets, you're smart enough to either A, figure out what's going on, or B, go to Google and look up some material on, some of your knowledge gaps and what you need to know. We're going to cover things without mercy. So Qt is a little bit complex in the sense that you have to learn all these things, and it has this massive learning curve on top of the massive learning curve that C++ has. And Qt itself doesn't really make a lot of sense until you know all these things, and then you see how they start connecting and working together to form an application. And that's really what this course is about, is design patterns, the interconnection of things, and how to do things a better way. So what does this course cover? Well, this course is going to cover common design patterns and practices as they're used with Qt 5. We'll cover design patterns and philosophies with code examples covering a wide range of topics. Again, see the prerequisites. You have to come into this with some foundational knowledge. Disclaimer, this course only covers Qt 5. I'm going to record a different course for Qt 6 when Qt 6 comes out. There's a reason for that. While Qt is known for backwards compatibility, there are some changes in Qt 6 that just are not going to be compatible with Qt 5. And rather than confusing people by saying, well, this video is for 5 and this video is for 6, I'm just going to freeze all of my courses and re-record them for 6. I really shouldn't have to explain this, because if you're taking this course, you're not a beginner. Again, this course is not a beginner's course. But the way software development typically works is once you have a running code base and a user base and a new version of whatever technology stack you're using comes out, you don't just instantly switch to it. No, you take your time, slowly migrate to it, test it out, make sure there aren't any weird bugs or massive rewrites you have to do. And on top of that, well, Qt 5 is going to have long-term support. It's just the way things are going to work. Anyways, some things that we're going to cover: classes, interfaces, inheritance, polymorphism, file structure, streams, so on. It's assumed you've read the table of contents. But the big disclaimer I wanted to put is we're going to cover Qt 5. So if you're coming into this for Qt 6, that's a different course. If you are looking for the Qt 6 course and can't find it, I'm probably in the process of recording it as you're listening to this. What this course does not cover. We will not cover Hello World, any of the prerequisites, command line or IDE basics, or specifics to your project's problem. And I have to kind of underscore that because a lot of people will take a course and then say, "Dear sir, I have a project due at noon. Here's my code, please fix it." It's not really what this course is designed for. It's assumed that if you're watching this course, you're an advanced and experienced programmer looking to find better ways of doing things. For example, if we create a QML application, it's assumed you know the foundations of QML. If not, it's also assumed that you know how to use Google and figure out how to learn QML. We will, however, keep things short, simple, and focused. Don't expect 3-hour long video segments. The whole point of this course is to find simpler, better ways of doing things. Conventions and standards. People get hung up on this all the time. There exists this mentality that if you're not doing it the way that Apple's doing it, or the way that Microsoft or Google are doing it, that you're not doing it the correct way. Well, nobody can really agree with anybody. That's why we have standards and conventions, because somebody comes up with their way of doing it, and then somebody else comes up with their way of doing it, and the two often don't line up. The example I used was Apple, Microsoft, and Google. All three massive companies, fully successful, but they have different ways of doing things. So abandon hope, all ye who enter. Programming is a complex topic, and there are numerous conventions and standards that exist. There will be some videos where I follow one standard and some videos where I follow another, and yet some videos where I just abandon all rational sense of logic and sanity. A design pattern is meant to be fluid, and it's meant to adapt to whatever convention and standard you're using. So at the end of the day, it really shouldn't matter what convention or standard you're using as long as you're following a pattern. Expect issues. This course is about problem solving. Mistakes will be made. Let's be realistic with each other. We're talking about complex programming tasks. There will be mistakes. If you find a mistake, let me know and I'll update the GitHub source code. If it's a really, really bad mistake, I'll redo the entire video. It's expected there'll be disagreements on how things are done, as programming problems typically have multiple solutions where there's just simply no best answer. We may even break some of our own rules. So for example, if you wanted to just write to the end of a file, most programmers are going to say, well, I'll open the file in append mode, meaning it's going to automatically move to the end of the file. Other programmers are going to say, nope, I'm not going to do that. I'm going to open it in read write. I'm going to seek to the end of the file, write, and then go backwards and verify that what I wrote was flushed down to the disk. And yet other programmers are going to go, I'm just not going to care. I'm going to open it in write mode and seek down to the end. All three of those ways accomplish the same thing. But each one of those has its own pros and cons. So just be aware that there are multiple ways to solve a problem, and I will probably make some mistakes. And when I do, just let me know and I'll fix them. These videos are raw and unfiltered. So traditionally in video training, videos are rehearsed dozens of times. They're highly edited. They've been reviewed multiple times for errors. They've been peer reviewed. You may even have like a dozen people sit around the table and go through the code line by line. And they're recorded in professional audio-visual booths. They may even hire a voice actor. So the person typing the code and the person explaining the code are two different people. And they may take that code and dub the voice over it. So the person's not even typing and talking at the same time. Yeah, we're not going to do any of that. So in the spirit of problem solving, these videos are raw and unedited. You're going to see and hear me in real time. And I want you to see and hear every mistake I make, and more importantly, how I overcome those mistakes and the thought process behind it. So sometimes typing and talking at the exact same time are not as easy as you think it would be. While I do try to be professional, you may hear me misspeak, I may mispronounce words, there'll be spelling errors. Again, I just made a mistake. You might hear dogs barking, bad words, a whole ton of WTFs. You have been warned. And special disclaimer, we're still in the COVID-19 pandemic here in the United States, so All of my neighbors are home, so you may hear dogs barking, you may hear lawnmowers, uh, loud booming bass speakers that my neighbor seems to love his rap music, things of that nature. I'll try to keep it super professional, and if I hear a lot of background noise, I'll just simply stop recording for the day, but just be warned, it's going to happen. What are design patterns? And this is ripped straight out of Wikipedia. In software engineering, a software design pattern is a general, reusable solution to a commonly occurring problem within a given context of software design. It is not a finished solution. These are not complete programs. So, it can be transformed directly into source machine code. Wikipedia loves overly explaining things. Rather, it is a description or a template on how to solve a problem. It can be used in many different situations, and design patterns are formalized best practices that a programmer can use to solve a common problem when designing an application or a system. This really goes back to our conversation about conventions and standards here, where everybody has like their own unique way of doing things, and companies create their own conventions and standards, but a design pattern really bridges the gap and can go to any one of those. So what you learn here, you could take and apply at, say, Microsoft or at Apple or at Google or your little, your own business or your little mom and pop shop down the road, that kind of thing. So a design pattern is really just how to solve common problems. Why even bother using a design pattern? I mean, what's the point here? Well, they don't really teach you a lot of this in school, or they do teach you at a very high level, but it doesn't really make a lot of sense because usually when they teach you a design pattern in school, you're just starting off in programming. You don't even understand why you would need this in the first place. So, why would you use a design pattern? Well, code can be complex, but a pattern should be reusable, well defined, solve a specific issue, easy to use, proven, and most importantly, simple. Meaning you can take this design pattern and apply it to a wide range of utilities, applications, problems, and situations. And honestly, once you really nail down design patterns, you're going to look like a rock star at whatever company you work for because they're going to slide a problem in front of you and you're going to go, oh, yeah, I know that pattern. It's very simple. And they're going to look at you like, how the heck did you know that? Challenges with design patterns. There's always a better way. Code is constantly changing. Today's innovative solutions are tomorrow's legacy code. It's just a fact of life. It's the world we live in. The goal is to make a design that lasts a really long time. Rarely, however, is there a best or correct answer to a complex issue. Use what works for your situation. Now, I'll give you an example of this. Back when I was a young lad, there was no such thing as cloud computing. There was no even internet. I mean, believe it or not, I remember growing up playing, what was it, Pong on the little black and green screen with the two bars, and then that turned into 8-bit graphics where you had Pac-Man and all of its 8-color glory. And then 16-bit came out, and then 32-bit, and now, oh my gosh, we have fully immersive three-dimensional worlds fully connected to the cloud. Some of these games are just insane. They're so realistic. So, one of my all time favorite quotes is by Thomas Edison. And I won't get into who is better, Edison or Tesla, but there's a way to do it better. Find it. So, the goal of a design pattern is something that you can take with you as things change. So, for example, the code we write now, hopefully, will stand the test of time and work 10, 15 years from now, even though technology is not going to stay in the same spot and it's going to constantly evolve. Where to get help? You may get stuck, I often do, and well, there's a few places you can get help. First and foremost, the Udemy course Q&A. Really great resource, however, it can be a little bit slow and it's limited in what you can put in there. It's great for conversing with fellow students, however, remember, they are also students. So many of them may not have the answer, so you're really just talking with people who may not know. I'm also not always available. Really great example, 3 a.m. Thailand. So I'm here in the United States. I have students all over the world. This one in particular, who I shall not name, was in Thailand. He signed up. He got some sort of discount. I made a whopping not even 10 cents. I mean, I can't even buy a cup of coffee with what he paid for it, but regardless, he's a paying student, so I'm going to help him. Well, he starts asking questions. I'm assuming his local time, but my time it was 3 in the morning. So I wake up on my day off of work, log into Udemy, and at 3 a.m. till about 3:05, not even a 5-minute span, he had sent, I think, like 20 Q&As. And it starts off with, "Dear sir, I am stuck, I need help." And within the space of 5 minutes, remember, I'm dead asleep, it divulges into, "Why are you not helping me? I have paid money for this. I give you 1 star." And I'm like, whoa, calm down there, buddy. So I had to message him, and turns out he was stuck. He was frustrated, and he flipped the 1 star to a 5 star. But point being, I'm not always available. I'm a human being. Shocking, I know. But a better resource, I would say, is the Void Realms Facebook group. It has 3,000 plus programmers in it. It's an open community. It's available 24 by 7, 365 days a year. Most of them have a lot of experience. A link was sent to you when you signed up for this course. Now, I want to really put out there that this is an open community. They are under no obligation to help you. So if you come in with an attitude, expect them to just laugh at you. But if you just come in and say, "Hey guys, I got this problem," probably before you even flip off the page, you've got 1 or 2 people typing a response. I'm in there constantly asking questions and answering questions myself. And I'm blown away by this community. There's a lot of other communities out there, but I just wanted to throw that out as a resource. This is Qt 5 Design Pattern Section 2. This section is going to go over SOLID, which stands for Single Responsibility Principle, Open Close Principle, the Liskov Substitution Principle, Interface Segregation Principle, along with the Dependency Inversion Principle. And we're going to talk about keeping it simple, along with don't repeat yourself, access modifiers, encapsulation, the Qt property system, and code deprecation. All right, so this section we're going to talk about being solid. Now, what is solid? Well, it's an acronym for 5 design principles intended to make software design understandable and easy, flexible, and, well, it should just work. I mean, at the end of the day, that's what we're getting done is code. We want things to work. So what solid really does is it breaks it down into 5 respective parts. S for single responsibility, O for open close, L for Liskov substitution principle, I for interface segregation principle, and D for dependency inversion principle. These are a little bit tricky. So what we're going to cover in this specific video is this single responsibility principle, or SRP. Basic terms: do something simple, do it well, have a single responsibility, and do what you say you're going to do. I can't tell you the number of times somebody sends me a class that says dog, but the dog is flying around and mowing the lawn and doing all these things that dogs just don't do. So let's take a look at a good example here. So we're going to go new. Let's go ahead and make a console app. And this is 2-1. And I'm just off the screen here going to grab some notes rather than typing all of that out. So we're talking about the single responsibility principle. So what we're going to do is design a class that has a single responsibility here. So we're going to add new class, and let's call this temp converter. So our temp converter, well, there's different types of temperatures out there, but really what we're going to be focused on is, well, how to convert between Celsius and Fahrenheit. So let's go here, and I'm just going to paste in the function names rather than try and type all that gobbledygook out. We'll be here all day. So Celsius to Fahrenheit, Fahrenheit to Celsius, and these two, while simple on the surface, are easy to screw up. And it's very tempting to add a lot more that we don't need. for example, void to int, or, why would we say void to int? But you know what I mean. It's very tempting to add a lot of what are called utility functions in here, and we really, really shouldn't. There are better ways of doing that. So keep it simple. Do what you say you're going to do. So let's actually finish this thing out here. So we're going to right-click, refactor, add definition, switch back. If it seems like I'm whipping through this, it's because, again, we are not in beginner's land. So we're going to convert from Celsius to Fahrenheit. Judicious use of the auto keyword, and we're going to say O for output. And we want the value times 9.0. I'm probably really screwing this up because I am not a weatherman. And we're going to say plus 32. So that should convert Celsius to Fahrenheit. And then we need to go ahead and return our output. Could have all just done that on one line, but I felt like doing it this way. So auto output equal. Some people don't like auto. I think it's actually a dream come true for C++, but it is what it is. So from going from Fahrenheit to Celsius, we want to go value minus 32. And then we want to multiply that by 5.0, divide that by 9.0. Again, I am not a mathematician. I'm not an expert in weather patterns. I probably have screwed up the math on that, but it should give us a fairly close representation. Now, I'm going to just say it. We're not really focused on this little algorithm here. We're focused on the overall pattern, which this is why I love header files, because it takes all of that implementation and hides it. And we can say, okay, so does this class match solid? Meaning, is it simple? Is it easy to use? Does it have a single responsibility? Yes, it does. It converts from one temperature to another, and it does exactly what it says it's going to do. It converts a temperature. It doesn't mow the lawn or refrigerate the food or anything like that. So a lot of people, and I'm going to try and talk while I type, so bear with me. A lot of people will learn programming, and then there exists this mentality to add everything humanly possible into a code class or an application of some kind, and it's just the wrong way of doing things because it makes it unmaintainable. So we're going to say, whoops, temp converter, call this T, and we're going to say int value, and let's say 32. And let's go ahead and convert to just this raw value. Let's say we got this from a temperature sensor on a hardware device or something like that. And I'm going to say Celsius to Fahrenheit. And we want to say T, and we want to say Celsius to Fahrenheit. And because we've followed this pattern, most of this should be dead simple. We can just copy, switch these around. Fahrenheit to Celsius. Bang. Simple, easy to use, dead simple to maintain, does exactly what it says it's going to do, and if we run this, it should give us fairly accurate results. I think, I'm not an expert, but I think Fahrenheit to Celsius is 0. There we go. Moving on in the solid design concepts, we're going to talk about the open-close principle. Now, when you hear open-close, your mind immediately thinks about like files or sockets. If you open it, you should close it. Well, that's resource management. We're really talking about code. So software entities should be open for extension, but closed for modification. What does that really mean? It means you should be able to write something that's extendable, i.e. future-proof, but you don't want to modify the original intent because you could easily break it. And I'll give you a good example of how we could break something. Looking at QSSL socket, it inherits QTCP socket, as it should, right? You have a straight through dependency there. The problem is if we do something in TCP socket, it could potentially break anything that uses QSSL socket. Am I saying that Qt's wrong? No, I'm saying that there's not always a best way to do something. if I were to rewrite the socket class, I probably would also inherit QTCP socket, but I would be very torn when I think about it in terms of being solid, especially in open close, because if I modify the socket, I could break the SSL socket. All right, so let's take a look at a little bit more basic an example here. So I'm going to make a console application, Q5 design patterns 2-2. And like most programmers, I like coffee. I mean, I like coffee a lot. So we're going to make an interface here. We want to be able to brew coffee. So I'm going to add new, make a header file here, and let's call this iBrew. Sounds like something Apple would sell, the iBrew 3000. But anyways, we're going to put this under interfaces. And ooh, that does not exist. So let's just take this out. And let's go ahead and plop in a interfaces folder here. Now that we've got our header file in all of its beauty, and we're going to say include Q string list, and then we want the iBrew class, not to be confused with the new iPhone. So public virtual So we're going to add the ingredients. We're just going to add that as a Q string list. And if we really don't want to mess around with copying objects, we can just do that. And of course, virtual void, we want to brew because we want our actual coffee. I just will do zero work until I get coffee. All right, so we've got our little interface here. Now, again, I'm using an interface. You can feel free to use inheritance. I usually don't trust inheritance because it's too easy to break things in the future. Now, let's go ahead and let's make a coffee shop here. So we're going to add new. And this is going to be the consumer of any iBrew object. So we're going to say shop. All right, so here's our shop in all of its glory, and let's actually make it do something. So we're going to say Q debug. Now we want to include the interfaces, iBrew interface, and we're going to just use that directly here. So we're going to say void sell drink. Sell me my coffee, or I will come over that counter and make it myself. So QString list, and we want to do iBrew machine. Notice how I'm kind of breaking my own rules there. I'm using a pointer instead of a reference. It's all good. Now in our little shop here, we want to be able to actually do the work. So we're going to say QInfo, take the order. Whoops. You're going to hear whoops a lot. Talking and typing is incredibly hard for me for some reason. Not sure why. So machine, add ingredients. And here we're just going to add our list. And then we're going to say machine. Let's go here. There we go. Keyboard was not my friend. And we want to actually brew. And then we want to, of course, do other things like, take the payment. And then, of course, give me my coffee. All right, so shop is pretty simple, pretty straightforward. All it's going to do is say, hey, do something. Now, what we want to do next is actually use this shop. So we're going to put in a little bit here, and then we're going to switch gears and actually make the classes the shop's going to use. QDebug. And I'm going to, while I'm thinking about it, grab some notes and just copy and paste them in there. So when you download this code off GitHub, you've got all the notes right here. All right, so we've got our QDebug, QString list, and let's go ahead and include our shop. Now the shop's not going to do much right now because we don't have any coffee machines. So what we're going to do here is we're going to say shop, and let's go ahead and say QString list. Call this list, and let's just add some things. So we're going to say I want sugar. I actually don't. I drink my coffee black, but my wife likes it with sugar. And then some people like that added flavoring nonsense. I just drink it black. I don't know why. I read somewhere if you drink your coffee black, you're a psychopath. And I'm like, I'm really not, though. I just like dark coffee. I don't know why. So now what we need to do is actually call our shop, sell drink. Now, before we do this, we need some sort of machine to do the brewing. So notice how we've got an iBrew pointer to machine. So let's back out here, comment that out, and let's make some implementations of our iBrew interface here. So first thing we're going to do here is we're going to add new, and we're going to make just a very basic coffee machine. This is your standard coffee machine that you spent like not even $10 for. It's probably sitting on your kitchen counter. It's been there for 30 years. All right, so here's our coffee machine. And there's nothing real fancy about this. So we'll say Q, debug, and then include QString list. And of course we want our interfaces iBrew. And then we need to implement that interface. So we're going to say public iBrew. We're just going to right click, refactor, and insert virtual functions of base classes. Move this up here where we can see it. And we want the add ingredients in the brew. And let's go ahead and make sure it's in the implementation file with the override. And ta-da! Didn't screw it up that time. So now let's go ahead and flip into our actual coffee machine here, and this is where the magic happens. This is where we make beautiful, delicious coffee. So we're going to say for each, and I want a QString item in our list. Pet peeve of mine. And then we're going to say QInfo. So I'm curious to know how you guys take your coffee, but I just drink it black. I mean, don't know why, just like it black. And then we're going to add the item in there. I tried some, it was like a French vanilla creamer one time, and oh man, that was just, it tasted horrible. I was like, why would you do this? What monster did this? All right, so QInfo. Now we need to actually brew the coffee. So we're going to heat. Then we're going to QInfo. And nothing real fancy here. We're just showing that, hey, we're going to actually do some stuff. That's really all it is. QInfo. And then it's going to like beep or let us know something that the coffee's ready. You know, a very basic coffee machine here. So let's flip back over here. And let's make our coffee machine. So we're going to say coffee machine, and let's just call this machine. And let's take our shop. We want our list of ingredients, and then we want our machine. So really, what are we doing here? We're setting up the stage for future-proofing our application. Instead of saying this function must take a coffee machine, we're saying use an interface instead. So by using an interface, we're following that open-close principle. You should not modify this interface, but you can absolutely modify these classes. All right, let's flip back here. Save run, very simple, should work. Okay, yep. Take the order, adding sugar, adding flavoring, heating, pouring, beep, take payment, give customer their order. Everything works as we expected it to. Now, let's say our little company grows and we've got 1,000 people, is that even a word, 1,000? 10,000 people waiting in line, and we need a better coffee machine. And we need something that adds a lot of caffeine into this. So we're going to say add new class, and we're going to make the Caffeinator 3000. This is some big monster caffeine machine, if I can even spell caffeine. Maybe I need more coffee. So Caffeinator 3000, Q object, next, next. And let's say the Caffeinator 3000 is this humongous object, and we're just going to make life a little simple here because that's what this course is about. So we've got Q object, Q debug, Q string list, iBrew. Notice we're following the similar pattern here. And then we're going to implement the iBrew interface. Ta-da! Switch between our header. And let's go ahead and let's say, we want to do some shameless marketing. Let's flip back here. So we're going to just say, get rid of this iBrew interface. I personally am not a fan of marketing. I don't like marketing people. I hate it when they call me and want to extend my car warranty, that kind of thing. But the Caffeinator 3000 has a huge marketing ploy behind it. So we're going to do a for each. And we'll say QString item. And this is going to be out of our list. And let's say QInfo. Probably could have just copied and pasted that right out of the old coffee pot here. And if we were using inheritance, we would have just actually called add ingredients straight out of the coffee machine here. All right, so very similar. Now, this is where the Caffeinator 3000 gets really awesome, is in its brewing. So we're going to say QInfo, heating, and then let's grab this. We're going to do some marketing also. Marketing? Boy, I misspelled that, didn't I? Let's go back and fix that. Marketing. There we go. Get rid of that. So in here, we're going to just do some stuff. So we're going to say int I equals 0, I is less than 10, because we don't want too much marketing. It just gets annoying when you get the loud marketing going on. And then we're just going to say, let's see, we want like flames. So we're going to say fire. And then we want loud music, like some trendy hip hop beat or something. And then why not? Let's just take this to an extreme here. We're going to super inject caffeine. So that's the Caffeinator 3000. It's mostly marketing. You now know my secret. Okay, so we're going to say marketing. And then we're going to, of course, just pour the coffee. So yes, that's right. Like most things, the Caffeinator 3000 really doesn't do anything that a normal coffee pot would do. It just makes it look really cool with fire, loud music, and super injection of caffeine. Whew. All right, so let's flip back here. We live back in the ordinary world, and we're going to say, okay, boss. Marketing department's all hyped up. They got this brand new Caffeinator 3000. Let's go ahead and do this. So let's get rid of our standard old coffee pot. Let's use our C3. Let's call it C3000. Why not? Some really trendy, I mean, even marketing standing over my shoulder going, give it a cool variable name. I'm just rolling my eyes right now. Anyways, we got our Caffeinator 3000. We're going to just follow the same pattern. Sell our drink. And then, of course, it's going to be over the top because it is the Caffeinator 3000. And really, let's not get hung up on the details here. This is just ridiculous. It's marketing. But it works. And because we're using this interface and we're following solid, and we're using the open close principle, meaning once this interface is written in stone, we should not modify it. Now, anything that uses this interface should just work, no matter just how crazy your employer or the marketing department wants to take it. It should just work if you followed solid up to this point. Now we're going to talk about the Liskov substitution principle, and it's very simple. It's objects of a program should be replaceable with instances of their subtype without altering the correctness of the program. It also says see design by contract. Now when you see contract, you should think interfaces, and this right here is actually why I personally, my own design philosophy, have switched to more of an interface design rather than inheritance, simply because it's so super easy to break something. The example we used previously is the QSSL socket inherits QTCP socket. So if you change something here, you could break this, and if you change this, you could basically break the underlying class, or at least the way it thinks it's going to function. Let's take a look at an example of that. Got just bare bones application up in here, and let's a little bit of copy and paste. That way, if you download the code, you've got my notes. All right, so we're going to add in networking. And once Qt Creator calculates the trajectory of every known thing in the universe, we can move on. There we go. I'm joking a little bit. It's actually pretty snappy, but I get impatient. All right, so we're going to say new class, and let's make a socket. So we're going to say my socket. Next, next. And sockets are interesting because it would be pretty challenging to make an interface. You'd have to re-implement everything itself or call another object. So inheritance does make sense, but it's now super easy to break things. So let's just break something. I'm a huge fan of breaking things. Whoop, TCP server. I already broke something here. We want TCP socket. And then, of course, we want the Qdebug. Now, what we want to do is focus mainly on this practice here and look at how we could easily break something. Let's take close. We take QIO device close for granted quite a bit. So now we're in close land, switch in here, and let's say QInfo. Do something before closing. And of course, normally we would actually call close. But what if we forgot to do this? You guessed it. That's the open close principle in a nutshell. And it's also, when I say the open close principle, I should say resource open close. If you open a resource, you should close it. But it's also what we're talking about, the substitution principle, meaning if we want to substitute the TCP socket for the mySocket class, we have now broken the expected behavior. See how simple that was. This is why you got to really be careful, especially in C++ land. So let's go ahead and go in here, Qdebug. And let's just make a very, very simple application here. Why are you not helping me out here? Fine, I'll just type it. IntelliSense did not want to work with me there. And then we're going to say and there's going to be a bit of copy and paste going on here. So we're going to say connecting, and then we want to say connect to host, voidrums.com, my website on port 80. Feel free to substitute that with whatever website you want. And then we're going to say, whoops, I really screwed that up, didn't I? Apologies. So we're going to say socket, wait for connected, and we're just going to wait indefinitely. Really screwing up my typing today. All right, so connected, do something while connected. And then, of course, we want to actually close. So we're going to say closing. And this is where the interesting bit's going to happen here, because we're going to call this socket.close. And we want this to do exactly what it says it does. But of course, we've broken that in our socket. I'm going to say if not socket.isOpen. Actually, let's say if socket is open, that would make more sense. Then we want to socket wait for disconnected, and that'll just sit here indefinitely waiting for that socket to close. And then we would want to do something else in the background, but we want to let them know, hey, we're complete. Now, this is a very rudimentary example, but this is very, very easy to do in the real world here. So just to recap, if we're using TCP socket, this should work just fine. Save, run. Oop. See, I made a boo-boo. There we go. That's one thing I do love about Qt. It's very easy to swap out objects. Save, run, and connected. Connecting, connected, closing, complete. So it worked as expected here once I figured out all my nonsense. Now let's go ahead and break this. We have our custom class, our MySocket, which inherits the QTCP socket. But remember, we forgot to close this. Therefore, what's going to happen? You guessed it. It's just going to sit there indefinitely. So we've actually broken two things here. We've broken the resource design pattern, meaning if you open a resource, you should close it. And we've broken the Liskov substitution principle, meaning we now have broken the expected behavior. So really nasty little bug here. And a lot of people that get into socket programming will go, why isn't the socket closing? I don't understand. And it's because once you inherit, you really need to make sure you understand what you're inheriting and what you're expected to do as the programmer. So once we do this, then it would suddenly magically start working again. Moving along in Solid, we're going to talk about the interface segregation principle. And this one's a little bit tricky. It says many client-specific interfaces are better than one general-purpose interface. Now, what does that really mean? We're going to dive into that. But as an example, I'm sure you've probably downloaded or opened somebody else's code, and you just see tons and tons of classes. I mean, just simply like opening a file could be like 15 different classes. And you may think, why do they have all this crap? Well, they're trying to follow the interface segregation principle. Now, I'm not going to really comment on whether or not they did that successfully, but let's take a look. So we're going to go in here. First things first, we're going to make some interfaces. So I'm going to go in here and make a new header. And we're just going to call this the IBAD. This is going to be our bad interface. This is an example of what not to do. And we're going to say class, the IBAD, that again sounds like an Apple product, public, introducing the brand new IBAD. Anyways, virtual, int, wings, and we're just going to make something that flies. Apple's going to build an airplane or a bird or something. Virtual int, and we're going to say speed, because if you're flying, you're going fast. And virtual int fuel, whoops. All right, so what is really the problem here? I'm going to stop it right here. What is the issue? Well, what we're saying here is that anything that has wings needs fuel. Not exactly true. Think of a paper airplane. There's zero fuel involved. You could get a bit over the top and say that you're expending fuel when you use your arm to throw it. Or but think about a bird. Birds don't use jet fuel, so why would you need this in here? That's really what this principle says is less is more. Have more than one interface. Don't build one ginormous interface and expect it to cover everything. So let's go ahead and add new. And let's go, I want to actually put these in a different folder here. And we'll call this iFlying. Public, and then we want the virtual void fly. Some of you love interfaces, some of them hate them. I use them just as general principle. It's much easier to play around in the interface than it is to manage an inheritance tree. Now, not all flying things have fuel, so we're going to make a separate class, or I should say a separate interface, and let's call this machine, or the iMachine, because machines use fuel, be it solar, diesel, whatever, geothermal, tectonic plates, something. Now, I know someone out there is going to argue with me going, not all machines use fuel, and you're probably right. I'm not going to argue with you. I'm just going to say, for this example, so refuel, because if it's using fuel, we want to be able to refuel it. So we've got our flying interface, fly land, and a machine interface, refuel. Now, this is different than, we could actually call this refuel, just so there's no disparity there. We've taken this bad interface and split it into two interfaces. Pretty neat. I wish I could just drag and drop it like that, but we're going to leave that there for now just because I'm being lazy. And let's look at how we would actually make our application using our interfaces now. So what we're going to do here is make some classes that use these. And I'm going to, you know what? It's just bugging me. I'm going to get rid of that bad interface. There we go. Qt Creator figured out what it was supposed to do. So we just have our beautiful little interfaces sitting here. And we're going to make some classes. So I'm going to make an airplane. This is going to be a Q object. And we're just going to go next, next, finish. And then I'm going to add in a bird. Not being specific on what kind of bird, just a bird. Doesn't really matter. All right, so let's crack open our airplane here. And we want to say and we're going to use the flying interface and the machine interface because this is an airplane. And we need to add in the public for both of those. Sometimes I think I type a little faster and this thing moves. So anyways, we're going to implement these interfaces real quick here. And doesn't matter which one we click, it's going to give us a nice list. We want to implement the machine and the flying interfaces. Bang, adds those in, even tells us which one is which is actually kind of cool and annoying at the same time. And then we're just going to switch in here and we're going to say, just so we know what the class is doing when we test it, there we go. Get a little copy and paste action going here. And obviously this would do some real world stuff, like you would have a whole process of taking off, flying, maintaining altitude, things like that, and landing, you know, the exact same thing, right? So we've got our airplane. We're going to work on the bird next. Just want to make sure that we can fly and land and it refuels. So when we look at our airplane, sure enough, we've got all those. Now the bird is not going to refuel. So let's just go into our airplane here. And we're going to grab these, grab that, get rid of this machine interface because we don't need that. Little right click, bang, bang, add that in. And then let's just go into our airplane here. I'm just going to grab these, why not? So you can see the bird's doing pretty much the same function. Birds can fly, birds can land, but they have no reason to refuel. Seems pretty straightforward and simple. Now let's go ahead and go into our main here, and I'm going to just, because I'm a huge fan of notes, copy and paste that in there. So if you go out to source code on GitHub, you can actually see that. Add in some screen real estate. And we want to include our files here. So we're going to include interfaces flying, and let's include interfaces machine. And we're going to include our bird. And let's go ahead and include our airplane. Now we're going to take a trip. And I want to be able to say, I flying. Now, you may be scratching your head going, now why wouldn't you just call bird and airplane directly? Well, this is why I use interfaces. So I can say I want to use the I flying interface, and it doesn't matter if it's a bird or an airplane as long as it uses that interface. So our object here can fly. You might also get hung up in details and go, whoa, 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 why are you using a pointer? Why don't you just do reference to? That way you don't have to worry about memory leaks or any of that. A lot of things in C++ land use pointers, so I try to, when I explain something, just get in the habit of using a pointer. That way I don't have to have the what is a pointer conversation, blah, blah, blah. But in the real world, I typically will use a reference rather than a pointer whenever possible. Now, we want to check the fuel. And of course, we don't want a flying interface. We want an iMachine interface. And then we're just going to say, notice how suddenly we can't land because it doesn't have that. Now we want to refuel. So we have two different interfaces we're playing around with. We've taken that bad interface and split it into two very distinct interfaces that do very specific things. Do one thing and do it well. Now let's go ahead and do a void test bird. And here we're just going to say bird. And we're going to take a trip with that bird. And we're going to say, voila, should work. Now let's go ahead and test our plane. So let's say void test plane. And then we're going to say the plane wants to take a trip. Again, this code is just dead simple, but we're really focused not so much on the code as we are the principle here. And the principle being, do one thing, do it well. Now it doesn't matter if we're working with a bird or an airplane, we can call the same code as long as we have that interface. All right, now let's go in here. And we run. Sure enough, the bird is flying and landing. The airplane is flying, landing, refueling. So we have two very distinctly different objects that do two very different things, but they have the same interface, I flying, but the machine, The airplane has the iMachine interface, so it's going to refuel. Now, if we had followed our previous design, the bad design, the bird would have to refuel, which would make no sense. Imagine just, shoving diesel fuel or jet fuel inside of a bird. You'd either kill that poor animal or it would go very, very fast. But that's the point we're trying to make here, is keep your interfaces, or if you're using classes and inheritance, keep them simple, keep them slimmed down, and don't bloat them. There's a very much a want and a desire for people to over-engineer things. Don't do that. Keep it very simple. Okay, wrapping up Solid, we're going to look at what's called the dependency inversion principle. This one will make your brain hurt. It says one should depend on abstractions, not concretions. What? And if you read a lot into this, it gets really confusing really fast. We're going to try and overly simplify it. I'm a bit worried that my example might overly simplify it to the point it actually becomes something else entirely, but we're going to try and stay on track here. So open this up. I'm going to paste in some notes. And dependency inversion principle, remember, keep it simple. The high-level modules should not depend on the low-level modules. And we've seen Qt break that before. For example, the QSSL socket depends on the QTCP socket through inheritance. And that's really what this says to avoid. Doesn't mean that Qt's doing anything wrong. It just means they're not following the dependency inversion principle for that specific case. Whew, man, that gets confusing. So let's take a look at what I hope is a simple example. Let's go new. We're going to make header. I'm just going to whip through this. I'm going to create an interfaces folder. I just like having my code nice and structured here. And we're going to say ioven. And then we're going to just make this super, super simple. This is not a class on how to make an interface, so public, and then we're going to say virtual void bake very, very simple. And then I want to eventually make another one, and we're going to call this iEvenHeat. Just making this now so we don't have to come back to interface land and build a whole new interface. So I watched a show called The Great British Baking Show, and so now I'm what you'd call an expert, and I realize now that when you're cooking something, you should probably flip it and maybe even rotate it a little bit to make sure it heats evenly. I am by no means an expert chef. If you've ever had my cooking, you would agree wholeheartedly. All right, so anyways, the iEvenHeat interface will say that we're going to flip and rotate the food, where the oven's just going to throw it in there and bake it. Two very, very simple interfaces. Now, let's go ahead and make a basic oven here. And we're going to say basic oven. Of course, it's going to be a Q object. All right, so our basic oven here, of course, is going to have a Q debug, our buddy here. And then, of course, interfaces, and we just want the oven interface. Because this is a basic oven, it's nothing fancy, right? So we're going to say public, and then we want the iOven. We're going to insert virtual function to base class. We want to put bake in there. Could have typed that out, but I am just super lazy, as most programmers are. It's actually one of my favorite quotes. It's actually by Bill Gates, and I know a lot of people are going, boo, Bill Gates, but he's got a really great quote. He says, I'm a lazy person as a programmer. I will stop at nothing to make my job easier or just flat out automate it to the point I don't have to do it. Really great quote by Bill Gates. Don't agree with a lot of what Bill Gates has done, but it's just is what it is. All right, so baking. And Let's actually put this in here just so we can say we're consistent in what we're doing. So the oven, the basic oven, is just going to do basic stuff like baking. Pretty simple, pretty easy to understand here. So what we're going to do next is we're going to make an advanced oven. So we're going to say add new, and we want to go with a class. All right, so we'll crack this open. Actually, let's grab this so I can just do a little copy and paste action. Wham! So you guessed it, we're going to have not just the iOven, but the iEvenHeat. I'm curious to know how many of you watch The Great British Baking Show. It has me glued to Netflix. All right, so we got the iEvenHeat, and then we want the public. Some of the things they cook on there, I'm like, how in the heck did you even bake that? It's just nuts. All right, so oven, iEvenHeat, we're just going to implement those virtual functions. Bang, most of this code is already written. Flip over here, and then we're just going to say QInfo. Help if I spell QInfo correctly. I'm going to say bake. And then we want to flip the food and then rotate. You know, I'm going to do this a little bit different here. This is an advanced oven, and we should do advanced things. So we're going to bake. We're going to do advanced stuff. And here we're going to actually call our flip and our rotate. And I mean, if we want to be fancy, we could put this inside of a loop, but you get the point. We're just doing some quote unquote advanced oven stuff here. So now we've got a simple oven and an advanced oven. Let's make what I call a bad oven. And we're going to go in here. Man, that would be one heck of a marketing strategy, the bad oven. I'd probably buy one, knowing me. All right, so we're going to include QObject. And what makes the bad oven bad? Well, not that it's necessarily a bad product, it just has a flawed design. And the flawed design is that, you guessed it, we're going to depend on that basic oven. So we're going to say QDebug. And then we want to do the basic oven, but then we're going to go into our interfaces and say we want to do the iEvenHeat. Wait, what? Why are we mixing inheritance with interfaces? It doesn't make any sense. So we're going to say, let's do basic oven. Switch this back. And we want the iEvenHeat interface. And now we've got something slightly different here. So we've got the iOven bake along with the basic oven bake and the iEvenHeat flip and rotate. Let's just add all that in here. Whew, that gets confusing. So which one's which and why are we using what? Well, let's find out. So what we're going to do here is we're going to say bake. Bake is going to say QInfo, and I'm just going to actually steal this right out of our advanced oven. pretty much doing the same thing that's doing. Wow, did I misspell advanced? I did. Embarrassing. There's no excuse for bad spelling. All right, so bad oven stuff. And then we're going to flip and rotate. And I can probably just grab these. So really, what have we done here? Well, we've pretty much done the exact same thing the advanced oven has done, but we've introduced a lot of design issues here. So namely, if we change something in this basic oven, the bad oven's going to break, or it has a high degree of breaking, I should say. So let's go in here and let's actually void cook. And I want to take the iOven interface, which we don't have yet, so let's... Got a little ahead of myself there. We're going to say basic oven, the bad oven, and the... Now we want the interfaces, so I just want to say all right, now we can play around with that interface. And because we have an interface, we can just simply say oven.bake, and it doesn't matter what we throw at that function. As long as it has that interface in there, we can do it. So we're going to say basic oven, advanced oven, and let's of course say bad oven. All of these should work. But there's some underlying flaws I want to talk about here. So and I'm going to put some notes in there. Still works, but breaks this principle, changes basic oven, will impact bad oven. That's what makes this bad. And this is the kind of problem that creeps up in code, especially in version control issues. So let's give this a good build, give this a good run, and everything should work. Sure enough, everything does. So we would build this, send this out to production, and then several versions later, newbie programmer comes in that we just hired and says, you know what? I have a basic oven, and that's not even remotely how this works. This should do something different, you know? Like blah, whatever blah is. Now when we save and run, notice how basic oven's doing blah. Bad oven is depending on basic oven, but it's not necessarily working the way we thought it would. So now we have this fundamental problem where we're expecting bad oven to follow this basic oven bakes blah, but it's not doing it. Now you could also say, well, you know, Brian, you screwed up very badly because you're not calling your oven. So like, let's go into bad oven. And you should have said basic oven bake, right? But the problem now is, how do we flip and rotate these things, right? So remember, our baking, we wanted to do this. Now we're doing this. Oh, come on. This is just a nightmare. How do we fix this now? Well, we could do something like this, where we could say, okay, well, let's get rid of that, and then do that. Ah, see, now I've fixed it. Now it should, yep, see, now it's blahing. Is that a word, blahing? But you get the point now. Because we're depending upon the basic oven, now we've got all of these things we need to keep track of, and we're intermixing inheritance with interfaces, which adds more complexity. And before you know it, you're just done. You're like, you know what, I'm going home for the day. I'll figure this out tomorrow. So when in doubt, do not do this. When in doubt, follow the dependency inversion principle, which basically says they should not depend on each other. High-level modules should not depend on low-level modules. Doing so could break things. Instead, depend upon an abstraction, which is why you see me using interfaces quite a bit. Okay, so the last few videos may have seemed overly complex and confusing. Why are we doing all of this stuff with interfaces and things like that? Well, we really don't need to. Well, that leads me to the next topic, which is keep it simple. It's the KISS pattern. Let's go ahead and plot this in here. Keep it simple, K-I-S. Now, just because a pattern exists does not mean you need to use it. I'm going to repeat that. Just because a pattern exists does not mean you need to use it. There's a mentality that if a program doesn't use the latest trendy buzzwords, that it's somehow not a good program. It's just intrinsically bad, and it's not the case. Simple is always better, and that is one challenge that I struggle with, because when I'm trying to explain something in a video, I have to make it overly complex to get the point across, and in my brain, I'm screaming, this should be simpler. I just get this voice in the back of my head going, why are you doing this? This makes no sense. Stop doing this. So let's give you an example here. Simple file I/O. And I'm going to do what I call junior writing, meaning I'm now a junior developer and I'm going to come in here and I have taken a design pattern class and I'm going to say, oh, I know Brian makes these interfaces, so I'm going to make a file I/O interface, or iFile I/O. And instead of iFile, it's I'll file I/O, just because I want it to be. Or say QString. Yes. So I'm going to make everybody in the office's lives much simpler, and I'm going to build this interface. So I'm going to say class iFile I/O public, and then I want the virtual bool write. And yeah, so now I need a string path and QString data. Here we go. Yes, my masterpiece is almost complete. So we're going to say virtual QString. I'm kind of chuckling as I do this because I've seen like coworkers and students and previous jobs and classes do this, where they just make it as complex as humanly possible, and there's really no reason for this. So real short, it's going to read, it's going to write and it's going to read, and we're going to be working with QStrings exclusively. Now we've got this interface because, well, I took this class and this class told me I should use interfaces because I'm following solid, and then we're going to add new, we're going to add this class, and we're going to say, okay, let's call this file system. And I'm in the file system class, I'm going to start putting every single file system function that I can possibly think of. Rename, delete, read, write, you name it, it's going to be in here. This is going to be my kitchen sink for everything file system. Now, some of you old school programmers are probably cringing right now going, oh, please no, don't type all this out. And don't worry, I'm not going to. So we're just going to put a simple example in here. So say qfile, and we want the include qtextstream. And we also want to include our interface iFilo. iFilo, I like that word. And we're going to say public iFile. And let's go ahead and refactor this. And yes, we are so smart. We got this in here. And you know what we're going to do? We're going to do an interface for every single thing that we do. Read, write, rename, delete, da da da. So we're going to have about 10,000 interfaces, and this class is probably going to be about 200,000 lines long, and it's going to be just this massive class. You know, I'm not going to do that, but just as an example of how crazy I've seen some people take things. And then I'm going to show everybody this class and tell them how proud I am of it, and then because they're not doing the same thing, their classes are dumb. I've literally seen people, I'm taking it a bit over the top, but I've literally seen students and coworkers do this. I mean, when I say coworkers, I was in a company and there was a seasoned programmer. Everybody told me how smart he was, and then I sat down with him and he made something very similar, and it was just like repetition of what already exists. So it made no sense, and I kind of sat him down and said, look, maybe this isn't my place, but there's an easier way. And anyways, we're going to just say Q text stream. And we're going to give it a file. This is where I start making mistakes and I have to pay attention to what I'm typing while I talk. And then we're going to say file to close. Notice multiple issues right up front. We're just automatically returning true. So we're not monitoring what we actually wrote or anything like that. We're doing a little bit here, but really this is a pretty bad function. We shouldn't be doing that. Very much demonstrative purposes only. And then we're just going to say QString value. Just going to make a blank value that we can return here. And then we're just going to go back in here. And because we're reading, we want to read only that. And then we're going to say the value and we want to read all on this. So pretty just basic code, to be brutally honest with you. I mean, it's very rudimentary. But the underlying premise here is that we are breaking the KISS, or the keep it simple design philosophy or design pattern, is that we are overly making this complex. So what's really going on here is, okay, we have an interface, and now we have a file that uses that interface that's basically doing things that we really don't need to do. Let's take a look at this and see how we could have done this a little differently here. So going to include some things here. So we're going to include iFile, and let's go ahead and include the file system kitchen sink class that we're building. And then we're going to say QFile. QTextStream, and of course QDebug. All right, so what we're going to do here is we're going to say make some functions, and we're going to do test.io. Going to just make this completely overly complex here. I absolutely hate doing this. To be brutally honest with you, my brain right now is screaming, stop typing, don't do this. Why are you doing this to me, sir? All right, so IO QString path. Hope if I did a QString. And then we're going to just say if io.write, I shouldn't say dot, pointer to write, path data. We're just going to say, are we able to write something? And then QString value equal IO read. And again, we want to just read that same file back. Q assert. So we want to actually just make sure we can actually have the same data back. I get so used to autocomplete helping me out that when it doesn't, I tend to slow down and go, okay, did I just break my computer? What's going on here? All right, so let's go here, and let's put in a little else, because we live in the real world where things often do happen. And we'll say Q critical. Boy, I really screwed that one up. There we go. And we're going to say complex IO test failed. So we want to make sure, basically, that we wrote the data and the data we read back is the same thing. And then we're going to just say complex. We can save just a microsecond of typing by doing that. And we're going to say file system, and call this FS, our kitchen sink. And then we're going to test IO, and we're going to say FS, the path, and the data. because as the author of this class, I said this is how you should use this. You shouldn't call this directly. You should blah, 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 blah. Man, that gets overly complex, and it just makes my brain hurt thinking about how many steps we have to take just to figure out what the heck's going on here. A friend of mine calls that following the breadcrumbs. Whenever somebody sends him code and says, why isn't my code working? He calls it, I'm following the breadcrumbs. And then we're just going to say simple. Have pretty much the same function prototype here. And we're just going to do it the simple way, the way we probably should have done it right from the start. We're just going to say path, bang. Now, how is this really different? Well, we're not making it overly complex. We're keeping it simple. And we're going to say open QIO device, and we're going to do this in read-write mode. And we're going to say, I want this QCritical. Simple test failed. All right, so once we get to this point, what we can do is we can just say Q text stream, and we're just going to keep this as simple as possible here. There's probably even a way to simplify this further. And we say stream data, and then we want the stream flush. Don't really need that, but I'm ultra paranoid that someone's going to run this on a different device like a Raspberry Pi or something, and it didn't like get there in time, and then the data's not there. And all right, so now that we've got all that in, QString value equal stream. Took the R out of there on accident. There we go. So now we got the stream read all. We're going to say file close because we no longer need that, so we should close it. And then we're just going to say Q assert. And we want to say our value equals the data. Simple test passed, and I'm almost embarrassed making this overly complex because let's be honest here, there's no need for any of this stuff up here. All right, so now that we've got that in, got my notes in, let's go ahead and make the magic happen, as we say. All right, so we're going to say QString path equals, and I'm just going to do it in the same directory as our executable. And we want data, hello world, why not? And then we're going to call complex, and we want to say path and data. And then we're going to call our simple, and let's call this path and data. There we go. And I'm going to comment this out for now. Save run. Should work. Complex IO test passed. Whew. All right, but what if it didn't? We would have to go to this function here. Uh-oh, now we're making a class, but we're passing this class to this function. So now we got to look at this function. All right, so now we've got a pointer and a path and blah, 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 blah. Well, now what are we doing with this IO read? So now we've got to go into this class, and first thing I see, well, we're using an interface. So what's the interface? And you get the point. You got to jump all over the place just to figure out what the heck we're actually doing. So if whomever's making this kitchen sink class does something here, everything that uses this class now breaks along with it. There's a much simpler way. Follow, you guessed it, the KISS design pattern, which is just keep it simple. All of that fits very nicely in one function, and I dare say you could probably even simplify this function even further down to a few lines. It's very, very simple. There's no reason to make this overly complex. Okay, all the things we've covered so far may not mesh well with the real world. When I say the real world, you often find you have to make hybrid classes, and that's where dry comes in. Dry says simply, do not repeat yourself. That's literally what it means. And the longer description is every piece of knowledge must have a single, unambiguous, authoritative representation within the system. What? What does that even mean? It just means be specific, don't repeat yourself. That's really all it boils down to. So think of it in terms like this. An interface is a contract. A class is an implementation. Inheritance modifies the implementation through inheritance. You kind of have a little triangle going on here. Now let's take a look at this. So first thing we're going to do here is we're going to make some interfaces. And I'm not going to spend a ton of time here typing all this out. So we're going to create our interfaces folder, and we're going to call this the iFridge. Again, sounds like an Apple product. Copy and paste is going to be a very simple interface. Bang. A fridge chills and freezes. Very simple, does what it says it does. We're going to add another one. And this I could actually see Apple building, called an iRadio. I pick on Apple, but I actually love most of their products. They're a little overpriced though. All right, so the iRadio will play and stop. No way should a radio freeze and chill, and no way should a fridge play and stop. Right? Wrong. Welcome to Marketing 101. Marketing now wants a refrigerator with a radio in it. Ugh, what a programming nightmare. Well, that's where dry really helps us out, along with all of the principles we've talked about so far. So let's flip in. We're going to make a basic fridge here. So we're going to go add new. And let's call this basic fridge. And make sure we're in the right folder. Next, finish. I have a nasty habit of putting my stuff in my interface folder, and it just drives me insane when I do that. All right, so we're going to grab some stuff off the screen, a little copy and paste, make life a little bit faster. And then we're going to go in here, public iFridge. And we're going to add those in. Very, very simple, very easy to understand. So now we have our implementation of our interface. We're not following inheritance, so we don't have to worry about breaking something or having our thing being broken through the inheritance chain. And we're going to do basically the same thing with a radio. Add new, class. Make sure in the right folder. Next, finish. And where's our basic radio? There you are. Whoop, do not want to set a breakpoint there. That would have made running that a little interesting. We're going to add the new Apple iRadio into that thing. There we go. Going to be able to play and stop. Keep it simple. Keep it easy to understand. Do what you say you do. Really, really not super hard here. All right, so basic radio. Let's go in here, and we can actually just borrow some of these things. In case you're wondering why I'm typing this and not copying and pasting, I kind of pull up some song lyrics and paste them in there, but I was like, nah, that's a little bit cheesy. Let's not do that. All right, so now we've got some very simple things going on here. But now the boss comes in and says, hey, marketing has got this amazing idea. We're going to take a fridge and put a radio inside of it. And we're going to call it the advanced fridge. Again, I hate these marketing guys. They drive me nuts. So advanced fridge. All right, so next, finish. And I'm going to copy and paste some notes in here, along with some includes. So this is a hybrid object that's going to have interfaces and inheritance. What? Didn't we say we shouldn't be doing this? Hold on. Whoa, whoa, whoa. Why should we not do this? Well, that's a good question. Let's find out. Let's go public basic fridge, but we also want our interface. So, let's see here. We don't want to put the interface up here, meaning we don't want it to depend on this interface, but we want to use the interface. So how do we get around that? Well, first things first, let's switch into this. All right, let's actually fix our fridge here. Direct base, oh yeah. Thank you, copy and paste, for screwing me all up. There we go. All right, so first things first. The advanced fridge is going to have, well, advanced fridge options also, like a deep freeze mode. It's not good enough to freeze your food. You gotta deep freeze it. Again, marketing, I'm sorry, but add that definition in there, and we're going to say, put that food into a deep freeze. Really, the difference between a freeze and a deep freeze, there's not much, but it's marketing. Now, how do we use this iRadio interface? We don't want to put it here because we don't want this refrigerator to become a radio. Remember, an interface is a contract, and we don't want to treat this refrigerator like a radio, but we want to have the radio functionality in it. If you're thinking getters and setters, you're absolutely correct. So let's go ahead and do a private and iRadio. This is why I love interfaces. Doesn't matter what type of radio we give it as long as we follow that radio interface, and then we can create the getter and setter functions. Bang. Right click, super simple, and of course it's already put it in there for us, saves us a small bit of typing. Wow, that is extremely cool once you think about it. So now we can use the full features of the radio, but we do not have to become the radio. It's like the existential question. Are we all radios? Am I the radio? Are you the radio? Anyways, let's go in here and let's watch these things work. So we're going to, and we're going to say void test basic. And we're going to say basic fridge. Probably help if I include some things first here, huh? And let's go ahead and include our advanced fridge. And we're going to go here and we're going to say we want a basic fridge. And then we're just going to do very, very basic things. We're going to say the fridge should chill. Chill, fridge, chill. And then the fridge should freeze. Very, very simple. Now, we also want to play around with our advanced fridge, our marketing ploy here. Now, our advanced fridge has the same things because it is also a basic fridge, but it also has this deep freeze function that marketing demanded we put in there. But we want to be able to turn the radio, like imagine you're looking at a fridge and there's a radio in the front panel, and we want to be able to turn that off or on. And maybe it has like Wi-Fi and Bluetooth and all those fancy gadgets in there. And we're going to say if fridge radio, because remember that's a pointer, so we want to make sure we actually have an object on the other end of that pointer. Then we're going to say fridge radio dot play. I shouldn't say dot play. I have a nasty habit of doing that. And then let's go ahead and stop. So we can listen to some music for a while. So really, how does this follow? Don't repeat yourself or dry. Well, we're not rebuilding an entire radio inside of the advanced fridge. We're just saying, give me a radio object. And we're not forcing the advanced fridge to become a radio, which by proxy we would have to build a radio inside of this thing. We're just saying, give me a radio object and I'll work with whatever object you give me. So we're not repeating ourselves, we're not reinventing the wheel. All right, so let's go ahead and go over here, and now we want to include our basic radio. So now we've got a basic fridge, advanced fridge, and a basic radio. So let's go ahead and go basic radio, and we'll call this just simply radio. And let's say basic fridge. And then we want an advanced fridge. We'll call this, I'm just struggling for a variable name right now. I'm like, what do I want to call this? So, and then we're going to say a fridge set radio, and we want to set this as the radio. There we go. Our instance, and we can actually just seems very rudimentary, very, very simple, and admittedly, it is. So let's go ahead and test basic. We're going to give it our fridge. Actually, I'm going to do this down here. So, and then we're going to test our advanced fridge here. Now remember, this is expecting a basic, but because we're using inheritance, both should work. Save and run. Sure enough, both the advanced and the basic work because they both have inheritance. Now, close this. Let's go ahead and test advance. Save and run, and we can actually play and stop music. Pretty cool. Now, because we are demanding an advanced fridge, we cannot pass the basic fridge to it. No question there. But what happens if we wanted to do something different? Like if we wanted to make a new type of radio? Well, it's very simple, and rather than jump through all the steps, I'm just going to explain it. Because our advanced fridge just takes a radio, or the radio interface, we can hand it any type of radio device. It's taking iRadio. So it doesn't matter if it's an AM/FM radio, a CD player, a iPod for freezers. I don't know if they even make those. I don't think they do. Anyways, doesn't matter. As long as it's following that interface, it'll just plug right in and work beautifully. So let's take a look at access modifiers. And this is something that we probably taken for granted since our introduction to C++ class. So when we talk about access modifiers, we're going to talk about this from a Qt perspective. So an access modifier determines how members of a class can be accessed. We know this, it's pretty simple. But Qt adds a layer of complexity, namely signals and slots. We're going to look at an example of QTCP server, so we want to add in our networking here. Once Qt Creator figures out what it's doing, there we go. And I know I pick on Qt Creator quite a bit, and I probably shouldn't. It's one of the best IDEs out there. We're going to add a new class. Let's call this myServer. And I'm just going to add some notes in here real quick. So just a recap from our beginners course: private is only this class, public is any class, and protected is only this class or its subclasses. Notice that presents a problem if we're using an interface, because an interface is not a subclass of this. That gets frustrating very quickly. So let's go ahead and include. And let's include our socket. I'm going to add in our server, flip this over. And then let's go ahead and refactor, insert virtual functions of base class. And then we want this incoming connection. And spoiler alert, this little guy has caused a lot of headaches throughout the ages here. Qt keeps changing the type, and then it just magically, like you'll upgrade from one version to the next, and then it just won't work. So if that happens, that's why. So when in doubt, if your incoming connection ever fires off, look at the type. So anyways, this is using a Qt int pointer. And there it is, voila. Now, let's take a look here. So this up here is private, public, signals are public by default. Because if you think about it, you're never calling a signal, you're only emitting a signal, therefore everything needs to see it. Protected though, only this class or its subclasses can see it. And if you think about that, that's true because we need to inherit QTCP server in order to use this. That's why it's protected. Whew. All right, so the cool thing we can do here are slots. Let's say we want to work with signals and slots. We can say private, protected, and public slots. And then we could put anything we wanted in here. And these follow, you guessed it, the exact same principle. Even though they're signals and slots, they are really just functions under the hood. A lot of people think that there's some special magic that happens, that there's some new, earth-shattering paradigm or something like that. No, really, it's just a normal function with some cute magic wrapped around it. But it still follows the same rules. So we could, if we wanted to, go into our private slots here, and we could say void handle socket. QTCP socket. Now, this really becomes a design choice. Where do we want to put this? Do we want to put it here or here? Personally, I'd put it in private, and here's why. Let's say we take our socket, our handle socket function, and we go in here and we say, if not socket return, and then we want to do something with that socket. So we're going to say somebody out there is going, you lied, you said no hello world. Well, I also said we would break our own rules, so welcome to the course. Anyways, so socket, we're just going to write out hello world, and then we're going to say socket, wait for bytes written. Notice I'm not being very nice about that. I'm going to wait indefinitely for those bytes to be written. And then I'm just going to say socket dot close. And then we're going to go ahead and delete the socket. Delete. Boy, I think that would fry my system, but delete socket. There we go. What is the inherent danger of this function? You guessed it, right here and right here. So those two lines. So if somebody's handing us a pointer, they're trusting us to take care of that. They're like, here's my little baby pointer, do something with it. And we are saying, well, we're done with it, and we're deleting it, so it no longer exists. So if the caller here tries to use this, even though we've deleted it, you guessed it, boom, their program just dies. And then they blame us because we deleted their pointer. Oh, that's why I would put it in private. Because I don't want somebody inheriting this class and then it's in protected land, they try using it and then go, why does this pointer keep getting deleted? I don't understand. That's why. So we're going to say QTCP socket equal new QTCP socket. Don't really need to do that because we are doing the memory management, but just because somebody out there will say you've got a dangling pointer if we don't. Then we're going to set the socket descriptor handle. Note, if you are trying to work with this and the incoming connection never gets called, check that data type because Qt keeps changing it. If it's different than the version you're using, like it used to be like in QINT64 or something like that, then that's why. It's the signals and slots aren't lining up and it just won't deal with it. Then we're going to handle the socket. Now notice how we're not connecting signals and slots. We're just calling this directly. Again, a slot is just a normal function with some meta objects attached to it. There's a little bit more to it under the hood, but that's basically what's going on with signals and slots. So it's 100% fine to make this a slot, but still use it as a function. Whew, that's a lot of talking. All right, let's take a look at our little application here, and let's make this thing work. So we're going to say and let's just drop down in here and we're going to say my server, and we're going to say if server listen, qhost address any, meaning I don't care, just use any address this computer has available to it. I'm going to say 3301. You may need to change that port. I had a previous tutorial where their virus scanner popped up, and because I had used a port, I think it was like port 2600 or something like that, it was used by a popular virus, let's put it that way, and they said, oh, you've given me a virus, you've infected me, because their virus scanner popped up and saw it was trying to use the same port as this known virus. I had actually never heard of this virus before because it isn't really that well known, but in this guy's mind, I had infected him and he was going to sue me and all this other stuff, but I had to sit him down and go, you have the source code, you typed it out, blah, blah, blah. I mean, just really baby step him through this. Kind of funny, some of the little problems you run into. All right, so if we've gotten this far, we're listening, and we're going to say, let's jump up here. And then we're going to close the server when we're done. I found on certain Linux variants, if we don't do that, the application will just hang. So whenever I do server programming, I tend to follow this method where I will grab the return value from a execute and then return it here rather than put it in a loop. Save and run. All right, we are listening. And I'm going to say telnet, our local loopback. And what did we say that port was? 3301. Tell it. That's why. Telnet. Thank you. Hello. So there is our hello world. So it works as expected, but again, we're not really focused on TCP client server programming. What we're really focused on here is access modifiers and the bad things that could happen. So again, design choice you'll have to make, but if you're going to move this to a protected, you need to really think about what you're doing, especially to this pointer. All right, so what have we really been leading up to? Well, you guessed it. We've been talking about encapsulation. Let's just take a deeper look at this. So you hear a lot about encapsulation, and I know personally, sitting in class, when you're learning about encapsulation, you kind of go, oh gosh, here we go. This is going to be super boring. And yeah, it probably will be, but it's actually very, very important. It's everything that we've just talked about at some point really is about protecting the data. I mean, making sure we don't break things long term. And that's really the foundation of encapsulation. It's the process of combining data members and functions into a single unit called a class. This is to prevent the access of the data directly. Access of the data directly. I see this time and time again. It just infuriates me when people break that. So let's actually play around with it. So I'm going to go class, counter, all right, then we're going to go in here. We're going to just our trusty qdebug. And then we're going to say, let's make a private area here. Now you could be saying, why don't you put them up here where it's already private? Well, some people do, some people don't. I tend to like to make my own little section. That way I know exactly where it is. but doing so leads to possibly this issue right here. So we're going to say mcount. And then void perform count. Notice how this lives quite happily down here in the little private area. We're going to make a public function. Void count int max. Pretty simple. People do this all the time. And then we're going to add definition. Pretty simple, pretty easy to understand. We're not doing any sort of miracles here. Notice our variables. We haven't initialized anything. So what are we really at risk of? You guessed it, uninitialized variables coming around and biting us. So we're going to do that here. Bad practice, I know, but I'm trying to illustrate a point. And we're going to say max is the max. Max is the max. Sounds like that should be a song. And then we're going to say perform count. So really what we're doing here is we want to count, we want to go to the max, we want to set these variables. We forgot to do it up here. Therefore, we're just trusting this. Then we're going to say max and I++, and then mcount, we're just going to increment. Nothing, I mean, we're not curing cancer, nothing super complex here. Very, very simple code, but there are some very real headaches that we could create here. So let's go in here and let's say we want the QText stream, we want the QDebug, and our little counter class here in all of its majestic glory. And then we're going to say void user input. Can't seem to type that today. I don't know why. I know it's about 1 billion degrees in this office right now. You can't see my face, but I'm like pouring sweat. So enter a number. And then we're going to say Q text stream. Stream, and we're going to say std in for the standard input. And then we're just going to read a line here. And that, of course, will block until we have a full line. So we're going to say bool, OK. Then we're going to say int max equals. If we're doing this really smart, guys, we're going to say toInt, making this a little more complex than it needs to be. And then we're going to say if OK, or I should say if not OK, then we're going to say Q info. Let the user know, hey, that's not a number. And all right, so we've headed off about 500 disasters here. We think we're being super, super cool. Counter, counter. And let's go ahead and try this out. So we're going to say counter dot count max. Everything should work. Help if we actually put the user input function down here. Now everything, drum roll, there we go, enter a number. So I'm going to say just some random junk, not a number, 12. Counts to 12, works as expected. Now, let's play around with encapsulation and break this. And it's a lot simpler than some people might think. What if we just simply Forgot to do that. Well, if we run our program, everything still just works. We can enter a crap, not a number. We can enter 45 and bang, it counts. And it works as expected until, of course, I move on to bigger and better things within my career and some newbie programmer comes in and goes, well, why are we doing it this way? I don't understand. Why don't we just say counter dot perform count? There, that way I don't have to worry about this variable thing. And then run this, and still works that way. I'm going to say 5, and then what just happened here? You guessed it. We didn't initialize the variable, and we haven't really encapsulated that. So now we're calling a function we really shouldn't, and we have completely broken this application. It's really, really broken. So, well, junior programmer goes, I know what I'm going to do. I'm going to say counter.mmax. There we go. Equals 12. I'm just going to set that variable. Now I'm going to say, test this. Perfect, it works. I only want to count to 3 and wait, what? What's going on here? What? I don't understand. We have broken encapsulation. So never, ever, ever do that. In short, why do we encapsulate things? To avoid these kind of catastrophes. And you'll see these all over the place. It's really mind-boggling that in 2020, and that may date this video, but in 2020 we see all sorts of encapsulation issues all over the place. Make sure I fix this before I upload it to GitHub. So when we encapsulate something, we are basically protecting ourselves. Think of encapsulation like being on a date. You don't really know the person you're talking to. They could be a nice person, they could be a serial killer. You don't know. So you want to keep your private business private and not really tell them any of this. Now, later on, if you move on and get married, you may want to do things that are protected, that are just between the two of you. I know that probably not a visual you wanted in your head, but that's really how you should think of encapsulation, is think of a class as like a living person. What do they want to display to the public? What do they want to keep private? And what do they only want to share with themselves? We've been talking about encapsulation. Now let's talk about Qt's property system. And unfortunately, if you're in C++ land, this really is not super helpful. I'm sorry, it's just not. However, for QML, this works beautifully. And it's probably, in my opinion, designed specifically for QML. But because QML is a little bit new, it's been out for a while, but still a newer technology, there's still bugs. So we may run into something called the invalid property name M16 or some other variant of that. So let's dive in and take a look at this. First thing, we need to declare a Q property, and we're going to go over all of this. I'm going to show you end to end how this works. This may be a longer video. There'll be a lot of typing. I may lose my voice at some point. So we're going to use Q property, and this looks really, really crazy, but it's super simple once you dive into it. It's Q property followed by a type, a name, and then whatever you want to do. And you have either read, read write, reset, or read write notify. So what are these reads and writes? This gets super confusing. So you have a type. This is just a variable type. A name, you can name it anything you want from brown cow to fuzzy bunny slippers, doesn't matter. Read is a getter function. Write is a setter function. Now we've talked about getters and setters, and if you're from a C++ land, this makes perfect sense. Getters and setters are the way to do encapsulation. This is where it gets weird. You can have a reset function as if QML wanted to reset that value. Why wouldn't you just use the set function? Anyway, so there's a reset function. Then there's notify, and this is a signal. So notify notifies whoever's talking to this property that it's changed. It gets super confusing, but at the end of the day, really, in QML, all you see is this name, and it acts like a property. You can say name equals or name is, and all of that just happens in the background due to this Q property. Oh, that gets crazy confusing. So let's just dive in here. Let's make a Qt Quick application empty, and QML and I, the editor, we don't get along some days, so might make some mistakes. I'll try not to, but we might end up saying some bad words. All right, so we have just this bare bones basic QML. We're going to close that for now because we're going to build the C++ class. I did say I'd make mistakes. Got a little tongue-tied there. So we're going to call this machine. It's going to have a base class of QObject. Go down to our sources, and as soon as Qt Creator figures out what it's doing, all right, I'm just going to slap in some of that, and I want to put some notes in our main file real fast while we're in C++ land. So we're just talking about the QProperty system. It's easy encapsulation and uses the QProperty system, blah, blah, blah. Really good for QML, not too great for C++. So let's dive in here. We're going to make a pretty simple class a little bit harder than it needs to be. And what I'm going to do here is I'm just going to save a smidge of typing. So we've got some private variables, count, max, name, and timer. So we're just adding a timer in here. And then I'm going to do some getters and setters here. So I'm going to say count, getters and setters, max, getters and setters. This is very rudimentary stuff for you C++ gurus out there. Same thing for name. So now we've got our getters and setters, and let's do some signals here. I'm going to just grab some off-screen copy and paste action here. Notice the naming conventions. Started, stopped, paused. These are actions that we're having some sort of notification for. We're going to emit started, emit stopped, emit paused. Max changed, bang. Count changed, bang. Now when I say bang, what am I talking about? We have count, set count, and count changed. So if we flip back to our conversation about QProperty, we have a getter, a setter, and a notification. So we have our getter, setter, and notification. Doesn't really matter how you name these, but as you're about to see, the IDE gets a little bit picky. And when I say about to see, we're still a few minutes out, but I'll definitely let you know when we get there. Once we start adding QProperties, it gets super frustrating super fast. So let's just go ahead and we're going to add in some slots. Bang. Just saving a smidge of typing there. So we've got some public slots, start, stop, pause, and private timeout. This is what's going to talk with our timer here. Okay, so let's actually flesh all these out. Otherwise, our compiler is just not going to be super happy with us. I want to make sure we get a good build before we try adding that property in there. Switch here, go to timeout. And let's just make sure we can build. Good. All right, so we have a good build. Just want to double check we got everything we need, that this class really makes some kind of sense here. So we have count, max, name, started, stop, pause, max, change, count, change with some slots of start, stop, pause, slot, timeout, and our private variables. Good, good, good. Let's flip into our implementation. And I'm going to just save a bit more time. Otherwise, we'll be here all day typing this out. We're just setting count, max, and then we're connecting our timer to our private slot timeout, setting the timer's interval. This is really C++ 101, or I should say Qt 101. We've done this before. This is where things get a little bit different, though. So we've got our getter for count. We've got our setter for count. So if we're going to use the property system, we need to really pay attention to the setter, and we need to say emit, and we want the count changed. And then we're going to emit our actual count. Now, why are we doing this? So what happens under the hood is we want to be able to set this, but then QML is going to connect a slot to this signal, and it's going to want to know when this changes. And that's how the property system works. Think of it like a triangle. You have a getter, a setter, and a signal, and those three kind of work in harmony. Same thing here. And I want max changed. Kind of weird the way that works. And did we put a name changed in there? No, we did not. We didn't really need it. So we've got those in there. And let me just go back here, making sure, yes, we didn't start any of this stuff. We didn't do any of this good code. So let's go into start. Just gonna say starting. Gonna start that timer. And then we want to actually emit the started signal. All right, so when we call start, really all we're saying is start our timer, emit the signal. Pretty simple pattern here. Pause, a little bit different. Actually, it's not different. It's exactly the same. Or is it? Let's go in here, stop that timer, and emit paused. There we go. So if we stop, we should probably reset this count, which means we're going to also do count change. Let's do that after this, though. Set count 0. Think of stop as like a hard reset on our machine. We could do this really any way we want. I don't want to get too hung up on those details. Now for our actual timeout, this is where we're going to say some sort of count is going to increment. Very simple machine. I'm just trying to show you how to interface with some sort of C++ class on the QML side. And then we're going to emit the count changed. Or what we could do, you guessed it, set count. Not going to really mess around with set count. I could say something like mcount equal mcount plus 1 or some temp variable or whatever, but just want to say, hey, count changed. Doesn't matter which way you really do it. And then we're going to say if mcount then we're going to just stop. All right, our beautiful machine in all of its glory. Everything should just work. All right, so what we need to do now is go into our header, and this is where we're going to actually build some properties, and this is where it gets a little bit confusing. I'm not a property fan, let's put it that way. So I'm going to say QProperty. Notice how it puts this little template in there automatically. So if I go tab, it puts that in there, and this is their naming convention, type name with a getter, setter, and then a notify. So it's a little confusing how they put that reset in the documentation, but the template has notify. All right, so we're just going to move along with it. I'm going to say int, and let's call this count. Notice how automatically it does it, but however, there's a small bug. Do you notice it? Look at the naming. Set uppercase C count, set lowercase c count. Go away, info tip or whatever that thing is. So you can sit here and drive yourself mad and try to do, well, I want that uppercase, and notice it changes these. So now those don't line up. Oh, super frustrating. So what you do is you just let it do its thing. You go to the end here and you just hit enter. And it goes through your code and tries to figure out the correct naming convention. Now everything should just line up. And if we give it a build, you notice how, ta-da, no build errors. Congratulations, you just made a property. So we're going to do the same thing, just copy and paste with our max. Notice how it did not magically change it for us. Ugh, frustrating. So this can get a little bit buggy is what I'm really trying to point out. So now we have count max. Now you may ask yourself, now should these be named different? No. This name right here is the name that the Q property uses. C++ doesn't know or care what it is. So you're not going to have some sort of crazy naming collision or anything like that. This actually under the hood gets turned into a Q string, which we'll show here in a few seconds. So let's go ahead and do a name property. So I'm going to say QString. That's right. Anything that uses the meta object system or is a meta type, you can use with the Q property. Very, very cool. So I'm going to get rid of this notify because we don't need that. And you notice how as I'm typing, boom, it goes through and figures out the correct naming convention. So what's really happening under the hood? Well, we get getter, setter, and the signal. And here we have the getter, setter, signal. And here we just have a getter, setter. No signal because we don't have that notify in here. If we wanted just a getter, make it read only, we would get rid of this part here. Pretty cool. Now let's go ahead and give it a build. Now at this point you're scratching your head going, okay, it's great that we've done all this, but how do we use it? Well, let's take a look at how we would use it in C++. And this is where you're going to be like, ew, what is this nonsense? So I don't mean to be super negative about it. It's just for C++ land, it does absolutely very little for us. And you'll see why here in just a second. So I'm going to say void, if I could type test. And we're going to go down here and actually call our and let's grab our machine. So we're going to include and let's go ahead and say QInfo starting C++ test, and let's make a machine. The rise of the machines. All right, so, and then we're going to say machine dot set count. So we can access those getters and setters like we would anything else. Very, very cool how that works. Honestly, there's not a whole lot going on here that we haven't already talked about, but let's go ahead and set the max to 5. Getters and setters in C++, you should already know this. We could say something like QInfo. Really, getter and setter, we could connect the signals and slots if we wanted to, and we could set the name and all that other fun stuff. But here is where you would access that property. Let's say we wanted to set the name of this thing. So we're going to say machine dot set property, and notice how now it wants a const char pointer called name. So let's call this, we need the name, and you're inclined to say name, machine name, stuff like that. Don't ever guess because it's just not gonna hook in right. So go into the actual name here and copy this guy, because sometimes if you have like an extra space or something, it does not end well. So paste, make sure you don't have like a trailing space or anything. Sometimes it just doesn't help us out at all. And we're going to say this machine is named Brian. So we've now set a property. And what happens in the background here is it goes in, looks for a matching name. So we could have done count or max. And then it says, okay, are we getting or setting? In this case, we're setting the property. So it's going to look for right. It's going to look for this function. It's going to call it down here, and then it's going to put whatever value we gave it. And of course, if there was a notification in there, it would also have the signal and slot bound in the background on the QML side. None of that happens in C++, which is why this is abysmally not helpful. We would have to go through and manually connect a signal and slot. You know, you get what I'm saying. So for C++, this doesn't really help us, but we can set the property and then QInfo. Let's read that back. And if we say name, we're calling that getter. Save, run. And we got to go to our app output, and we see we've set the max, and then we've gotten that name out there. So the property system itself is working. Now we're going to take this machine and we're going to put it into QML. And this is where things get a bit nuts. This is where I start saying very bad things. So we're going to say QML register type, and this is a type of a machine. And then we need to do some what I call magic numbers. And this is absolutely a horrible programming practice, but I understand why they did it. So we're going to say com.company. We have to give it a UID of basically what this thing is. And this is machine. They tell you to use your website, so it's backwards. It's com, company, and then machine. So it would be like machine.company.com. So it's just the reverse of that. That way you don't have like a naming collision. So this would be like Apple's machine or Microsoft. I'm not even going to type out Microsoft, but you know what I mean. And then you need to give it a major version and a minor version. That it's a point of contention in the QML community because Qt 6 versioning is going away. It's not really going away. They're more hiding it. But so QML register type of machine, com, company, machine, major, minor, and then the actual name. And this is the name we will register this with. So when we're in QML land here in about 10 seconds, we can actually go in and create an instance of this machine. Now we don't have to do like a set context property and all that. We can create as many machines in QML as we want because we've registered this type. We can do that because it is, drumroll, a QObject. And these properties make it super simple to work with QML. So speaking of QML, this is where bad things will happen. So we're going to go into the designer here. We're going to go into imports, and they got this microscopic print here. So I'm going to add in controls and then go back here. Sometimes the controls add, sometimes they don't. Ah, success, they're there. I'm going to zoom this out. In case you're wondering, it's just hold down control and then you move the middle mouse button to zoom in or zoom out. And sometimes it gets a little off track and you got to put it back. So anyways, I'm just going to put it like this. Now I want a column. I'm going to take this little column, drop it in there. And then in our column, I want a label. Now sometimes this filter betrays us. Let's see if it does it. So I'm going to just take a label, drop it in there, bang. Now I need a row, and let's see if it betrays us. Sometimes you'll do that and everything. Yeah, see, it did it. Darn it. So like, where's our row and stuff like that? It was literally just there, and it's not there anymore. And we could try to ... So the editor has betrayed us. Let's flip back to that and then flip back into design, see if it, yep, magically appears. Ah, super frustrating when it does that. All right, so we're going to go here. Like I said, if I'm going to say bad words, this is the video. So I have nothing against QML. It just, this editor gets a little frustrating, especially on Linux. So we're going to drop in some buttons here. Drop those right into that row. And let's do some spacing because this is getting to be a little bit crowded here. So let's say 25. And let's do that rows, 25. I'm going to save because sometimes this editor likes to go boom and crash on me here. And I'm going to grab yet another button. Yeah, I'm going to do it. And we're just going to drop this in the column so it appears down under the row. Editor, why have you betrayed me? says it's there. Oh, of course it won't let me scroll over now. Let's do this. Let's call this 350. Why not? There's actually a better way if you do property bindings, but I'm like just doing it the hard way just to be a jerk at this point. So let's go ahead and grab this. Grab this little label here. Those are off because this is off, and we can drag and drop that. There we go. So we've got this nice and neat. Now we can grab our column, grab this label, make this a little bit bigger, call this status, and let's actually give this, I'm going to save just in case this whole thing crashes on me. Once in a while this IDE crashes in QML Designer. That's why we are not friends, because I'll be halfway through a video and it makes doing a live video just kind of a pain. So we're going to LBL status. I know I complain about this. I think it has room for improvement, but honestly this is pretty much the best out there. And we're just going to have a little test button here. Could have very easily put test over here. I just wanted to separate those. We're going to call this btn start. Doesn't matter what we name these, to be brutally honest. And then, of course, our btn test. Now, from here, if you know QML, which you should if you're taking this course, there's like a billion different ways to do this. You can go in and you can go in and add a property. You can go in through the text editor and modify it through here. I'm just going to go to edit mode to get rid of all of that editing nightmare. And instead, what we're going to do is we're going to look at this and just make sure it's the way we want it. Everything seems to be okay. Let's go ahead and run it and see what the QML side of things look like. So everything runs. We have no compile issues. We have no application issues. All right, let's kill that and let's add in our machine. Now to do that, we need to import it. And this is where I'm going to say bad words. So how do we import this machine in here? We've already registered the type. We need to grab this guy right here. And we need to remember our major and minor version and the name. So I wish there was just a simpler way they could have done this, but I understand the reasoning why. So we're going to say import, and then I'm just going to paste, and then 1.0 was our version. If you get to this point and there's like a squiggly red line and it says, I don't understand what this is, you need to go back into your main and double check your registered type because you've goofed something up. Usually what I goof up is this guy or I have the wrong version. Spoiler alert, Qt 6, they're going to do away with the version. So most of your Qt 6 code should look like that. So it'll just import the newest version of whatever you got, I'm assuming. I haven't actually gone out and played with it yet. Now we're going to make a machine. And autocomplete should help us out, but sometimes it betrays us. And I'm going to say ID machine. And from here, we can actually hook into our signals and slots. So if we look at our machine, we can pretty much just go right down these. We've got started, stop, pause, max changed, etc., etc. So let's just go down here and go into our QML. And you can just start with the word on. Everything in QML starts with on. So I'm going to say on started. And it's not going to help us out here. Invalid property. We did find it. Why is it doing this? So invalid property name on started M16. I said at the very beginning of this video we may run into this. invalid property name X M16 for whatever. And if you read this whole thing, which I'll save you some time, basically it's a bug in Qt Creator, and we can test this out beyond ad nauseum. There's some people that say, well, you need to suppress it using this little guy, which the fact that you have to disable a check and suppress it tells me they know this is an issue and they haven't yet figured it out. But like this guy said, you can suppress the error, but sometimes it doesn't fire off, and then it's a version bug. So you have to update. And then it says try moving the imports around. So now it's being very fickle about which order the imports are in. So let's try that first. Let's grab this. And sometimes save doesn't really do what it says it does, so I'm just going to close all this, reopen it, and nope, it's still there. So they put this before that. So yeah, I'm not going to play around with this anymore. I'm just going to suppress the error, see if that does it. And I found that sometimes even disabling this check or suppressing it doesn't really work, but this time it did. So disable check doesn't disable quote unquote the error, it just gets rid of that red squiggly line. So if we take this back out, it reappears. So let's talk about why that is there to begin with, and I'm just going to put that over off the screen here so I have a note. So invalid property name. Why? Well, it's because they're adding these on start here. It still works, and let's prove this. So we're going to say LBL status.text equals, and then we're going to say started and plus machine.count of, and I'm going to say max. And it's unfortunate that it's not helping us and it's getting kind of fickle about all this. So let's just save run. Nothing happens. Ooh. Let's figure out what's going on here. So on started should be firing this machine. So let's go down to our start. Did we have any app output? No, we did not. I know why. We haven't done anything yet. Derp. All right, so that's embarrassing. All right, so I'm so focused on that M16 thing. That thing just frustrates me to no end. So anyways, let's go ahead and start our machine. Wow, bad words. I'm going to say some bad words on this video. I'm really trying not to. So anyways, we're going to just simply start the machine. And if we want to, we can actually do like a console.log. And then let's just take this and let's do the same thing. We're going to do pause. Pause. That's not even a word. So focused on that M16 error, that just will just frustrate you to no end. And stop. And then we can say, all right, now that we've got those in there, notice how this M16 thing's still there. Super frustrating. Save run, and our machine should work. See? Now we got to hook into these other ones here, so I'm just going to grab this. Actually, I'm going to grab this, and I'm going to say on paused. And I'm going to say on stopped. And we can actually say on count. And if you're wondering where I'm just magically coming up with these, you guessed it, it's our signals and slots. So we're just grabbing the signals. So I can literally just copy this. Count change. Now, this is the naming convention I'm talking about. our actual signal is count changed. And in QML, it's going to start with on, because this is the property system and how it binds into it. Count changed. And notice how now IntelliSense suddenly knows it's there. Interesting how that works, huh? Suddenly our M16 error magically went away. So something happened in the background where Qt woke up and went, oh yeah, I know what that is. Oh, that is frustrating when that happens. So anyways, I am going to put this suppress back in the code just in case somebody downloads this and they see it. Now see how it's saying unnecessary message suppression. So it's clearly a bug in Qt Creator. Anyways, I'm not bitter at all. Let's just run this and we should be able to start this. Pause it, start it again. Should be able to stop it, and it just works. So we have full integration with C++ using property bindings. Now what happens under the hood here? So this is where we're going to play around with testing a bit. And testing can get a little bit crazy. So be prepared for us to break some stuff. Let's take a look at our machine and really take a look at this thing. So I'm going to say machine dot, and oh my gosh, IntelliSense is magically working. So notice what's happening here. Count, max, max change, named, pause, stopped. What it's doing is it's going through and it's looking at our signals, slots, but ignoring anything public. And what I mean by that, you don't see a set name, you don't see a set max. And let's actually test that. We're going to go in here and we're going to say machine dot set, and see, it's not going to find it. If I type max, it just sees max and max changed, but it's not seeing set max. So I can't even say like set max 100. If I try to do this, whoops, save and run, and let's move this up, and I want to see this application test. Yep, bang. Type error property, so QML is working exclusively with the property system. Set max of object blah is not a function. Is not a function. What the heck, guys? Come on, of course it's a function. I'm literally looking right at it. It's right there. So short version, if you're going to work with QML and you want to do anything in C++, you have to use the property system. It will not let you do this. Now, here is a little trick. Let's say you really wanted to have this. Cut that, paste it into a slot. All we've done is change this into a slot. We can still call this like a function in C++. So it doesn't take away from our C++ functionality at all. And now, I'm not sure if this is going to work. When I say going to work, I mean IntelliSense. Yeah, so IntelliSense isn't keeping up with us here. If we do this, yeah, see now IntelliSense is broken again. Anyways, set max 100. Whoops. Give it a good build just to prove that nothing is broken. We're going to go to our app output. We're going to clear this out and let's run this. And watch what happens now when I hit test. Bang! Test actually worked. I can click that all day long. And just to prove that, we're going to go machine, set max, and let's actually do set max. I'm gonna put a little smiley face because I'm like happy. And we can actually go into QML and we're gonna say console. I'm just gonna like completely add a bunch of annoying stuff. Log. That way we see this full life cycle here. Clear this out, save, run, and we're going to bang. So clicked test set max. So simply by converting it to a slot, now we can access it in QML. So you're sitting here going, aha, I will never have to work with the property system. I'll just make everything a slot. Wrong. As with everything Qt, there's the Qt way of doing it. And see, this M16 check is back. Oh, super frustrating. The reason why we need the property system is what happens under the hood is QML says, okay, I only want to work with known properties because I don't want to have to go through and figure out what each one of these little things is. So under the hood, QProperty is building mock code through the meta object compiler using signals and slots. Okay, so really what this does is the property will say use any getter, any setter, but then signals and slots. In short, if you want to connect C++ to QML, you have to use QProperty at some point, especially if you want to do signals and slots. You can, if you just want to call a function, put it as a slot, and it has absolutely zero impact to your C++ code. But that is QProperty, the Qt way of encapsulation via QML. Let's talk about code deprecation. Now, what does that really mean? We're going to show you what happens in the full life cycle of some sort of class. So we're going to go to a console app, and let's call this Q5 Design Patterns 211. Now, like most of you, you're happily writing your code, and we're going to create a class. This is the birth of the machines. It's kind of like something out of Terminator here, right? So the rise of the machines. And as soon as Qt Creator figures out what it's doing, there we go. And then we're happily plugging away here. We're going to say Q debug. And let's go ahead and make a function. And this function's happily running away in the background. And we've got, release this in a library, and thousands of people are using this, and we become a rock star in the community, and well, none of that really happens, but you know what I mean. Our original's happily working away here, and we can say, I'm actually going to make this a little bit different. Jump into our main, and I'm going to just plop some notes in there. And let's go ahead and make a machine here. So we're going to say include So we're going to include our machine, and then we're going to say machine and we're going to call our function, and life just works the way we expect it to. Original code here, nothing really snazzy about that. But now there's a newer, better way of doing things. This is where things get really, really tricky. So if we were to change this original function, we have the potential to break a lot of other things, all the code that's using this function. Ooh, that's frustrating. So we'll make a new way. We're going to say void new way. Or let's just call it new code. Why not? And we're going to that way it's abundantly clear what's going on here. Now we have another problem. How do we get people to use the new code? Because, well, everybody's happily using this old code, but we want to now get rid of this old code. Well, we have to do this little guy here, and I'm going to just copy and paste it. Bang. So, declaration does not declare anything. Let's get rid of that. There we go. What this little macro here is doing is it's saying take this guy, and whenever it's used, saying uh-oh, it's deprecated. So, now we have a little warning. Anybody who goes to use this is going to say it's deprecated. Oh, well, wouldn't it be really, really cool if we could tell them what to use instead? Let me see if I can mouse over there. There we go. Warning. Original is deprecated. Has been marked explicitly deprecated here. What does that mean? Let's hit the brakes here for anybody who's never really encountered this. When you write code, you'll find a better way of solving the problem. And when you do, you don't want to go in and just delete this code, because then anything that uses that code will now break. So what we need to do is force people, even if it's ourselves, to use this newer way of doing it. Telling the world that it's deprecated is a good way of throwing a warning saying, hey, this may not exist in the future. You should use the new code. So now we're going to jump into our machine here, and we want to put some warnings. And I'm going to say pound warning. Oops, I actually did that in the wrong spot. There we go. Warning. Try the new code function instead. Now, of course, because things are a little bit different depending on your IDE and your editor and your compiler and blah, 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 I'm also going to put in this Pragma message. This is more for Visual Studio users. We may never even see this if we're in Linux or Mac. Again, it really depends on what your setup is. And you see it actually puts these warnings in here. So just having these in will actually create warnings. So if this was a lib and we were building the lib, now we've got warnings that are being generated. Now, it says, if we flip in here, it's been depreciated, or deprecated, sorry, not depreciated. I was thinking of something totally different. And if we go to build, we've got a boatload of warnings now, and it says, warning, try the new code instead. So it actually works the way we would expect it to. Now, what does this mean, really? Does this mean that our code is no longer good? Does it mean that our program won't run? No, absolutely. This thing will run just fine. So there exists this mentality that you should never, ever, ever use something that's been marked as going away. However, it'll work just fine. The only time this really comes into play is if you're switching versions. So let's say I'm on version 5 something of Qt, and they have marked this. Well, I know it's going away, and then I upgraded Qt 6, and they have taken that away. Now suddenly my program, no worky, and I've got to figure out what to use. Now if I try to build it, notice how, because that is gone, it says, well, you're off to your own devices to figure out what to do because you didn't listen to us the first 20 times we told you. Meaning that warning's not going to fire off because, ta-da, it's not there anymore. So can you use code that's been deprecated? Yes. Should you? It's a matter of debate. If it exists, you can use it. However, know that if you go to upgrade, it's going to not exist at some point and bad things will happen to your code. Doesn't mean that your program is somehow now inferior or inept or doesn't work. It just means that you are running a danger when you go to upgrade to a new version of whatever platform or whatever code base you're using. This is Qt 5 Design Patterns Section 3. We're going to go over exception safety and then the different levels. For example, the no safety, basic safety, strong, and the no throw guarantee, along with the caveats and pitfalls of each one. This section is going to be about exceptions, and let's take a look at this here. So we're going to say new console app, Qt 5 design patterns. This is 3.1, and I'm just going to paste this in here. So exception safety, and you can look that up on Wikipedia here. Basically, there's 4 types. There's no safety, basic, strong, and a no throw guarantee. And we're going to go over each one of these. This video focuses on no safety. This is where really bad things happen. This is where only the brave dare to fly. Let's put it that way. So this is where our program is probably going to crash. We're going to create all sorts of issues, and we really just don't care. We're just hacking out some code, trying to get it done as fast as possible. So we're going to say get int, and we're just going to make a couple little functions here, and we're going to say perfect code that never fails. I'm going to try and give you an example of what we're talking about as far as something that we would expect would never ever fail on us. So we can create a bool, we're going to create an int called value equals, and we're going to say, let's actually say qstring data. So we're going to say data to int. Now, this is a little bit dangerous here because it could just, massively fail. What if it's like hello world instead of an actual number? So we're going to say, give it a reference to that bool. Now we need to see if it failed. Otherwise, we're going to return the value. Now, I say perfect code that never fails, but yes, bad things could happen because we're depending upon other people, aka the Qt developers, to not fail in this conversion function here. But the rest of this looks pretty safe. Now, this is not necessarily a no-throw guarantee, although it's very close to it. We're going to live in the real world, and we're going to show an example of really what not to do, but you're going to see tons of it out there. So I say void user IO, and let's go ahead and I want to say Q text stream, and I should probably, put some includes in here. Probably be super helpful at this point. And then let's go ahead and go include. Why not? Let's use a Q list. And don't really need it, but just because I'm paranoid. All right, so let's go ahead and grab our Q text stream. And this is going to be a pointer to a stream. Instantly working with a pointer, we kind of go, oh no, bad things are going to happen. Nobody loves pointers. And we're going to work with a pointer to a list. So instantly, right off the bat, what's one thing that could go horribly wrong? That's right, there could be null values, or these pointers could be dangling pointers, and they're not set, which is very dangerous. So what we're going to do is just completely ignore that, because why not? Let's make this a little more complex than I wanted to. Enter a number and a name, and then just like an example here. So now we're going to do some sort of data parsing. We're going to say qstring value equal read line. Now you notice how we're already using this qtext stream, but we haven't even determined if it exists. So this is super dangerous. So danger, bad things could happen right there. And then q string list items equal value, and we want to just split that. Notice how we're using qStringList, but we don't have it in our includes. So that's another thing that could go horribly wrong. We're just assuming is included. Now, this will probably spark a whole controversy in the Q&A where people are going to say, well, it is included because of the way Qt does this, and that, and it's part of Qt core and blah, blah, blah. What if Qt changes? I've run into that myself, where I thought something was included, I switch versions of Qt, and suddenly, magically, it's not included anymore. That was a long time ago, but it did happen. So, and we're going to say items at. Let's go ahead and grab 0. And we're just going to say toInt, and we're just going to assume this works. And I'm just putting my thoughts in the comments right after, what each line, what could possibly go wrong here. Some of these things, there's just way too much to name, but. And we're going to do not append, at, there we go. We're assuming this exists. It may not exist. There may not be an item at 1. So What if they only entered one thing, and they didn't hit space? They just hit like the letter A. So then we've got two problems. It's not a number and there's no second value here. Then we're just going to say list dot insert, and we want the ID and the name. We're assuming we even made it that far. And then we're just going to come back and again, list may not even exist because we're using a pointer. So another bad thing could happen there. QInfo, you entered and then we were probably going to have, and I'm just going to, rather than type all that out, just paste in from my notes here. What's going on here? Well, what if we entered a number? So we've gotten all the way down to this point, but we're now saying list at whatever that number. What if we put in 257, but there's only one item in the list? Well, we're going to get an assert failure, the index out of range error. So that will be spectacular. And then we're going to just say user IO and then stream list. So we're just going to call this function over and over again until we die. So many horrible things in this little function that could just go completely wrong. And it says all past this function will call itself. So now we're getting this systemic issue here. We're saying, uh-oh, you are doing this incorrect, sir, and you may die. So even the compiler at this point is going, hey, buddy, are you sure you want to do this? Qtext stream. And we're going to just read that. This is a memory leak and potential crash. Bad things are going to happen there. And let's go ahead and make our Q list. And let's call this a string. We could have said Q string list. Now we're just going to call this user IO. And we're going to say stream and list. And of course, last thing on our notes here, no matching function call. What are we doing wrong here? Oh, that's why. Reference to. There we go. So we have something on the stack, something on the heap. We're mixing and matching them, which normally isn't an issue, but we're just assuming they both exist. We're saying enter a number and a name. We're just going to read that entire line. That could block forever. And this may not even exist. Q string list, item split, not a big deal there, but we're just assuming we got a value in the first place. And then we are saying, okay, convert to an int. We're just assuming that even worked. And then we're even assuming that there's even a second item here. And then on and on. I mean, just a whole bunch of disasters that could just completely destroy us here. But, save run. Does it work? Oh, it did not. You're saying, I know what the problem is. It's that index out of range. So let's say I came in and said 0, Brian. Now it magically works. 1, Tammy. Magically works. 2, dog. Magically works. 3, cat. But what if I do 54? Bob. Boop, dies. So this is an intrinsic problem we have when writing code, is that we just assume things will magically be there to work for us. And then we are shocked to find out something bad happened. So when we talk about no safety, that's really what we're talking about here. Is there is no promises, guarantees, or warranties of any kind that this will not completely just obliterate our program. So we're going to talk about basic safety here. So we're literally going to take the last example, 3.1. I'm going to just grab this, copy, close all projects and editors, add new, and let's go with Qt 5 design patterns 3-2, and we're going to add in some basic safety here. Same code from the last video. I am going to put a little bit different notes in here though, because we're talking about this guy, basic safety. Basic safety guarantee is the weakest of the three. However, it might be the best choice when a strong guarantee is too expensive in memory consumption. Now, notice what we're talking about here is a trade-off. The more we guarantee, the more resources we're going to use. So like a no-throw guarantee may be so expensive that depending on your algorithm, it brings your machine to its knees and it's just impossible to guarantee. Or the code is just so complex. So we're going to look at basic here. We are going to get rid of this little guy. And we're going to focus on user I/O. Now we've got all these little issues, these little gremlins that could come back and bite us. And we're going to fix most, but not all of these. So for example, first thing right off the bat, we're working with pointers. So we need to say, uh-oh. So if there's no stream, we want to do something. But we don't want to silently fail. So let's go ahead and say Q warning. Stream not set. Go ahead and return. So we fixed one minor thing that could come out and haunt us, but now we've got this other one. What if this list doesn't exist? Okay. Now we're going to have to do the same thing for list. We could say or, but I want to break these out and say list not set. You see how our code's getting longer almost automatically. All right, so read line. Well, this could take forever. So let's look at this here. Read line max length. So it's not going to give us a timeout of any kind, but it does have a max length. Well, let's set a max length of 255. And then let's go ahead and say value. Actually, I'm goofing up here. Let's grab this, grab that. So if the dot is empty, or is null, is empty is what we'll use. Then we're going to say no line. So this is going to sit here forever until a line is read, or until it hits 255 characters. So if somebody just like holds down the button on the keyboard, it's not going to sit there for 30 years until it eventually does a buffer overflow and your machine explodes. And I think QString has that built in where it will actually stop it at some point, but your program will just die. Okay, now we're saying split. So if we've gotten this far, we know we have a value, we know we have a stream and a list, and we can get at least to here. But now we want these two little guys. So let's, of course, do our friend the if statement here. And we'll say if items.length is less than 2, then not enough items. Okay. Now we've gotten this far, we can probably grab these, but you guessed it, now we've got to create a bool. So we're going to say, oh well, And then we're going to say right here, because we're doing some sort of conversion, our buddy, the if statement. Not a number. All right, so once we've gotten to this point, we can just assume that everything's working. Now we can insert that, and then we're just going to call this again. And we live here forever. or until the user breaks it. Let's demonstrate this. Save run. All right, so right off the bat, I'm going to say 1, Brian. And we didn't fix it. We're still having assertion errors. Why? You guessed it, because of the positioning right here. Bang. So let's go ahead and say there we go. So we're just going to grab that last item. Clear this eye out. Let's try that again. Hey, now it works. I can say 54 or 45 Bob. Everybody likes Bob. You entered Bob. Okay, now let's enter some gobbledygook like this. Not a number. Hey, so now it's not crashing. But you notice how our program has now exited out of this recursion loop. So we still have some issues, and we could actually resolve this if we wanted to by, putting it back in here or making it jump down to here, however we wanted to do it. But really what we're underscoring is that we have some basic safety. It's not perfect. It's very basic, very rudimentary. Really, we're just doing some sanity checks here to make sure this data is exactly, these variables and data are exactly what we're expecting them to be. So it's not perfect, but it is worlds better than no safety. Okay, so we're going to take the code from the last section and we're going to just bump it up just a little bit safer here. So let me take some notes. Boom. All of this is the code from the last section. This is what we would consider, well, a basic safety. Now we're going to move into strong. And strong says that a function goes out of scope because of an issue. It will not leak memory and the program state will not be modified. This pretty much goes hand in hand with what you'd call a commit or a rollback. And we're not going to really go into commit or rollback just because it's so cumbersome to really implement. But I want to talk about how we can make this strong. So when we look at this, what's the first thing we've noticed? We've had assertion issues. We've had things not working. We also have this memory leak down here. Or do we? We could actually get rid of that. Turn that there. Bang. There. Memory leak, go bye-bye. So we got rid of the memory leak. Now, what's the biggest issue we have with this thing? Well, things could happen, and things could happen very, very badly. So, let's take a look at this, and let's add some tries. So we got try catch, and I am admittedly not a fan of try catch. Qt really doesn't use it too much under the hood, and we're going to explain why in the next video. So now we've got this wrapped around a try, and we're going to add a catch all. We're super smart. We're going to catch anything that happens here. Now, the problem comes in right off the bat. If we go back up and look at the definition of this, okay, goes out of scope because of the issue, will not leak memory, and the program state will not be modified, meaning we're expecting this thing's going to keep trucking on down the road. Ooh, we've got all these nasty little returns in here. Well, that's kind of not good. So now we've got to go in and grab this guy, and pretty much everywhere we see a return, we're going to recall this again. Notice how this code is getting horribly, horribly complex, hard to follow, hard to track. I literally just wrote this, and I'm even sitting here going, no, wait a minute, what's going on here? All right, so now I've got to do this for each catch, because we're going to add some catches in here. I'm dreading doing this. So everything in my being is saying, do not do this, but we're going to do it anyway. So we're going to say catch. Thank you for helping me there, editor. I appreciate you. So catch, and we're going to say const, and we want to do an std out of range. Ah, yes, we are so smart here. And we're going to catch that assertion error where it's out of range. Grab this little guy, put him up here, and then of course we want to know something actually happened, right? So, I'm sure you've seen that before. Unknown error or error unknown, depending on what operating system you're using. Basically, that's what's happening under the hood is they used a catch-all because they don't know what the heck just happened. But C++ catch-all is deceptive because it does not catch all, which is why we need these extra catches in here. All right, so out of range. So we're just going to let the user know something happened, but then we're going to call it right back again, and we're just going to pretend like nothing to see here, move along, that nothing bad actually happened. And then I want to grab that little guy, and let's just do, not really sure what to put here. Let's just go error followed by what, so we know what actually happened. And I may actually put this up here as well. I'm just kind of babbling on at this point because this code is becoming overly complex to the point I don't like it anymore. So this is what we're really talking about. If we scroll up here, we started talking about how it was simple but error prone. We added a little bit of safety, but now we're increasing the complexity, and now we're adding a lot more safety and really increasing the complexity of this thing. So our little tiny algorithm is now massive, but we still have this all paths function thing, which we're going to fix in the next video. So just note we're increasing this. Now really what, if you want to do the letter of the law, like if this is written in stone, really we should try to implement some sort of commit or rollback, meaning we get to this point, where are we? We get to this point and we make a decision. Do we want to commit this? At this point, committing would be inserting into our list, or do we want to stop and roll back? And it's actually somewhat simple to do. We could say something like, if we haven't gotten any errors, we could get into it, but let's just say if, and I'm going to say list.length pop him in here, and then I'm going to switch this back to @id just so we can see what we're talking about here. Now remember, this always has an issue, so if I enter like 255 and that doesn't exist, it will have some sort of issue here. So what we're doing now is we're saying, okay, you entered, and we're going to just insert the name ID, and we could print these out if we really wanted to, but I'm not going to worry about it. I was thinking just for debug purposes we could just do a simple loop and print them all out, but you get the general concept here. Let's save and run this and let's test it out. Okay, so 0 Brian. All right, seems to be working. 1 Tammy. Some large number Bob. And oh, you notice how no boom boom. It immediately flipped back, and that's because we have a bit stronger. We've done, in a sense, a commit. Now, it's not a true commit or rollback. We're simply ignoring it if it doesn't jive with what we're trying to do. But the complexity is increased and the strength is increased. You notice how as we get stronger, this is harder to actually describe. So this is starting to break design pattern itself. Remember, a design pattern should be simple, easy to use, lack any mystery, and it should do exactly what it says. And well, this has started to really break the spirit of a design pattern because it's so complex and convoluted. Okay, we're going to take the code from the last few videos and completely redo it. We're going to fix it. So we're going to paste in some nodes. And what we're going to work on is the no throw guarantee. Basically, we're going to do this Very similar to how Qt does it. You notice a lot of Qt, if you look at their source code, does not use try catch, and they will return a bool. So let's look at how and why. And this gets a little cumbersome, and you got to kind of read through this, but basically you have to play detective and you have to outthink every single possible scenario. What if memory is going bad? What if we're out of memory? What if they enter some large string? I mean, all these possible things. So first things first, I absolutely hate this function. We're going to just destroy it, and we're going to say, I want to return a bool. We're going to change those from pointers to references, and notice instantly it starts complaining, saying, hey, wait, whoa, what are you doing? And I'm going to grab this little guy. And let's just, why not, give the user some feedback that we're going back through a loop. Do it again. All right, so now we have got control reaches a non-void, and these little guys appear. Now you notice how I'm working from the end, so this really becomes fill in the blank. So what we need is a bool and a return value of some kind, and we want to actually set this to false. We're just going to assume that this failed. Now we could always return true, that way this would always run, but we want to exit out of here. We want a no throw guarantee, but we still want this to work. If we've gotten this far, we're assuming the stream can do some things, and we have a list. So first things first, and I'm going to max that out at 255. And what we're going to say is if not, here we go, value, or I should say value, come on IntelliSense, help me out here, there we go, is empty. So if the value is empty, then we're going to return false. Well, actually, we could just return ret. So immediately, if we can't read that line for whatever reason, we're going to say, nope, we're done. We're out of here. So long, see ya. And then we're going to go in here and say, all right, now that we've gotten this line, what we want to actually do is make sure we can do something with it. So we're going to grab our name int ID. We're going to set that as a default value, and we could set that as a default. So now we've got our default values here, and we just want to read these out. So we're going to say qstring list, and here we're going to say items, and we want to value.split, and we're going to split on the space. Now we want to do some checking here. We're going to say if items length is less than 2, and instead of ret, if we really wanted to, we could just hard code this and say false, false. Notice how right off the bat, we're about halfway through all of that nasty code, and it is much, much easier to read. Simpler is always better. I hate to say that, but it is very, very true. So let's go ahead and say name equals, and we want to go items at position 1. We know that exists because we have a length of 2. Now we want to say ID equals items.at, and we want to say 0 to int, not uint, int. There we go. Now we've got a little bit of a problem here. What if this conversion didn't really happen? So now I'm going to add a bool in here, and I'm going to say ret instead of our OK. And we could, if we wanted to make this a little simpler, move it down here so it's a little more readable and we know what we've got going on. We could actually move it here. That way we're not creating this until we need it. Now what we can do here is say if not ret return false. Now some people aren't going to like the word ret, so we can actually change this to OK. And I'm just showing you how things get simpler and simpler as we go. Much easier to read. Variables should be pretty easy to understand what's going on there. So if we've gotten to this point, it's a fairly good guess that we could actually append to this list here. So we're going to say, all right, list.append, and let's go ahead and add in the name. But we have another problem here. Remember, we were doing it where you entered a number and then the name. So let's back out and figure this out a little bit better. We're going to say if ID is less than the list length, I want you on a separate line. There we go. We're not going to trust that list append. Instead, we're going to just say list insert, and we want the ID, name, going to get rid of that comment. That way I don't confuse people. And then we're going to say ID equals so what are we really doing here? We're saying, okay, if the number they gave us makes sense, then go ahead and insert at that number. If the number doesn't make sense, get the last number here. Now this is zero base, so we may have some issues we have to clean up later, but the point I'm making here is we're not crashing the program. We could just say, you know what, I'm not going to live with any of that. I'm going to just force them that if they do this, we're just going to append the name and the ID actually equals the length. So it really didn't matter what number they gave us. We're just doing that. And we could do a map or whatever you want to do. Point I'm making here through a very convoluted example is that trusting the user to tell us where to put something could make bad things happen very quickly. So multiple ways we could do that, but really we're going to stick with this way. If the ID is less than the list, then go ahead and insert it where they told us to. Otherwise, flip these around here, we're going to go ahead and append, and then we're going to say, hey, give me the ID, the index of the last item there. That way we can pretty much, beyond a shadow of a doubt, understand that's going to work. From there, we can say, if we've gotten to this point, return true. All right, so much simpler, fits on an entire screen, and we could actually get rid of a lot of this white space if we really wanted to. We could, if we really felt like it, put a catch-all in here, but it's probably not going to help us at that point. If we got to rely on a catch-all for this code, then something bigger is happening, like we've got some sort of bad memory or something like that. So the biggest stumbling block in this code is going to be this little chunk here, which is why I was kind of micro-focused on it for a few seconds. And it's because you really need to make a decision on how you want to handle that user input. And it may vary based on your situation of what you want to do. This may not be the desired effect. You may want to say that if that position doesn't exist, then you just notify the user and say, hey, doesn't work that way, sorry. All right, so from here, I'm just going to notify them we did something. And we're going to just spit out the ID, and then that, and the name. We have that recursion under control, we've got the pointers under control, and this thing is about as solid as we're going to get it. Looking at it, there's about a dozen other things that really come to mind, but I think we'll be here for another 3 hours talking about them. Let's just run this, and let's go. And 5, y. Notice how I put it at 2, so we know that's working. But what if we just say A and B? Oop. Does it still work? No, it does not. So we screwed that up again. Why? Because we exited out. Remember, we're saying while this is true because we're returning a bool. So we need to let them know. Complete. And we could actually say, let's grab this. That way it's a little more user-friendly. All right, so we're going to say 1, Brian, 2, Tammy, 54, Bob. Notice it puts Bob at 3. And I'm going to enter something that makes absolutely no sense. Complete. So this is a pretty good example of what we're talking about here. We can enter just random trash. We can enter information we're not expecting. And we can enter invalid positions in the index, and it fixes it, and it returns a bool. This is pretty common of what Qt does under the hood. If you've ever looked at Qt's code, they don't really rely on try-catch very much. And the reason why is, well, try-catch really doesn't help you most of the time. If you've got some sort of problem, like if you need a catch-all, you've got a bigger coding issue you need to work through because you're relying on error handling to really help you, and you shouldn't. So, is this going to 100% no-throw guarantee? Probably not. No-throw guarantee is almost impossible to do. In the real world, this should have a transaction-based system, so we should be pulling the number in, checking that number, making sure it's a valid number, blah, 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 blah. Once we got to this point, then we would actually commit the transaction and return the value back to the user, saying, yes, we were able to commit the transaction, but doing that would be probably a 9-hour video. And by then you would say, forget it, I'm not going to do any of this. I'll just stick with basic because it's easier. So the general takeaway for this section is that the stronger you make your safety, the more complex it gets, and guaranteeing is almost an impossibility. This little guy here could still crash. We could make this crash if we really, really wanted to. But we are pretty close to no throw as humanly possible.